policy for digital research data management. Each one of those two policy documents, they are long, but in summary, in short, the point is for all those unclassified, unrestricted digital research data products and software products, fully or partially funded by DOE, they need to make publicly available. And you may wonder when is the time or a deadline to make the data and software publicly available. I mean, the answer is the sooner the better. But one thing to keep in mind is there's a requirement in those policies is that if you publish a paper that analyze some data or use some software for data analysis, that data products and software products needs to be made publicly available before your paper is publicly available, basically published. So you need to think about that at an early stage to make sure that won't affect when you want to publish your paper. And of course, we want to follow the FAIR principles, make sure the data are organized and curated and documented in a way that they can be easily funded, accessed, and interpretable and reusable. And then we want to guide our management practices using the CARE principles. And this is especially important when we work together with our community partners, like the citizen science research projects. And of course, we want to make sure that we inside the project, we want to manage and exchange and share data more efficiently, and also want to make sure that our community partners can access the information in a way that they can benefit from it. Okay, so that's the objectives. That's really important. So many of you probably remember last year at the all hands meeting, we sent out 2 surveys, one data survey and one software survey. We asked your inputs. And the purpose for those surveys was, okay, we want to have a good understanding of the software and data products that BSEC is or will be producing. So we're maintaining kind of a radar. We want to keep all those products in our radar so we can better help you. So we've got like 21 responses so far, and here I just want to give you a brief update on what we've got. So this is the type of the data products that BSEC is or has or will produce. And most of them right now we've got a measurements, so consistent with our understanding. But we also got model outputs and some survey and interview data planned or in progress, and also a citizen science data product that's in someone's consideration. This is the status of the data products. So you see in this chart, actually a lot of the stuff that we got through the survey, many of the data products are already available through other repositories, like either through HydroShare, EDI, the Environmental Data Initiative repository, Zenodo. So we want those. We want to know about those data products. These data products pre-existed even before BSEC. They may not be funded by BSEC, but they play a very important role in supporting BSEC's research and applications. So we hope to build a single catalog that we can bring all the either data generated by BSEC or data affiliated or supporting BSEC. So we want to put them together. So we provide a single gateway. So when you come to the gateway, you see everything. You find the data that might be of interest to you more easily. But we also, of course, we have some data already available, ready for public release. And we also have some data products planned, but not available yet. And some like still working on getting the data wrapped up. So even you have something in mind that probably will not be finalized in even the next year or two, it's still good to provide your inputs through the survey so that we know what's coming, so we can properly arrange our kind of support to better assist you getting the data and the products published. And this is the scene by scene. We have a lot of actually the vegetation soil ecosystem. That's because we grabbed a lot of the pre-existing Baltimore ecosystem study data sets as affiliated data products into our kind of the survey catalog. We also have some other like atmospheric dynamics, building energy. So we have a pretty diverse category of collection of different data products. So some of you probably have heard of this, the MSD Live multi-sector dynamics living intuitive value-adding environment. This platform is a DOE funded data repository, not just data repository, it's more complicated than that. It offers more features and capabilities. But this is the main platform that we are leveraging to kind of manage, share, and publish our data and software products. As of yesterday, we had 27 users registered on MSD Live under the BSEC project. We have 16 data records published on MSD Live. So that's really a good number. I hope that number can grow really, really quickly. I'm expecting we're probably gonna hit like 100 data products eventually. And this is a tiny URL. I think Darren helped to create that URL that can take you directly to the list of all BSEC data products on MSD Live. And I really encourage you to sign up an account on MSD Live and join the BSEC project on MSD Live, which I'm going to quickly show you how to do that shortly. This is a live demo that I plan to do because you've heard MSD Live multiple times. I'm not sure if and many of you have actually seen how our data are organized and look like on MSD Live platform. Let me switch to the web browser. Okay, so this is the MSD Live homepage, msdlive.org. And scroll down, you see a few different categories, data and code repository. This is the main thing I'm going to show you today. Let's click on that. And there's an option to discover data and another option to submit data. Let me quickly show the discover data first. Click on that, you see a list of data products because it's not just us leveraging MSD Live. There are many other DOE funded projects are using MSD Live as well, but we can use the filter here, project, BSEC, UIFL, that's us. You see the number here, 15? Not sure if you can see that, but you see the 15 records associated with BSEC UIFL. This is 15, not 16, because there's one record currently marked as restricted. That means if you have a data record that you want to keep just within the BSEC project, that you don't want the public to see it at this moment, you have the control to make that happen. So let me click on that filter. You see, this is the list of 15 openly visible data records from BSEC. And you see, this is the Doppler LiDAR process the scans that Nick and the PSU team put together. But let me first log in. And once I log in, you see something different. Okay. Okay, so I think I have to apply the filter again. Now you see the number is 60. That's because the account that I have is under the BSEC project. So for any team member within BSEC, that restricted data record is still viewable, accessible to you, and that record is this one. This is the WRF 2021 control run output that Elliot put together, because this data set was kind of a preliminary product, and it's good to keep that within the BSEC project for now. So we restrict it, and you can see that label here. So keep that in mind. You do have the option to like share within a small group at the beginning. So don't hesitate putting your data in MSC Live. You can do that early, and you have full control of that. The other thing I want to show you is let me go back to the first page and scroll to the Doppler LiDAR data set. This is the data set that Nick and the PSU team put together. Now, one thing I want to point to you is you see the versions section on the top right corner. So you see we had a version 0.1, and now we have the latest version of version 1.0. So this tells you that you can make a very preliminary data available through MSC Live. You can mark that as restricted, visible within the BSEC team. And once you improve the data set, and at the point that you feel comfortable to release it to the public, to make it like wide open to the public, you can do that by creating a new version. So you maintain kind of a series of versions and revisions of the same product in the same platform. And you can control which version is visible to the public and which version is visible only within the project. So this is really a benefit. And also you see the DUI and a formal citation created for this product. So if this product is going to be used by some researcher either within BSEC or you never imagine who would use the data, they can properly cite your data product, you can get the credit. So that's really important. And this is a nice simple data viewer. You can see what's included in this data package. It's really nice that Nick organized the data by properly, by year, by month, and the file format is in the NetSTF format, and we actually worked together to kind of design the file structure, the format structure, so that they are compatible with the standard. So it's easier for other users to use the data. And you can download data files directly from the web browser, or you can download the files from the command line tool if you prefer. So this is one example of a data product that BSEC actually collected. And if I can go back to the projects section, this is the list of the projects that are using MSC Live to manage data and the software products. And BSEC, this is us. That's the most recent one that we joined on MSC Live. And you see the button here, join, because I'm already a member. So this button is grayed out. But if you're a new member, after you sign up account in MSC Live, you can come to this page and request to join the team. And then because I'm sitting on the back end, I can see all the messages and notifications from you, and I will approve, and you will be part of the BSEC project team on MSC Live. Another thing I want to quickly show you is the computational resources. So this is one thing that I just mentioned. MSC Live offers more than just a data and software repository. It also offers currently, at least currently, free cloud-based Jupyter Notebook resources that you can leverage to develop some like tutorials or some interactive data dashboards. So this aligns very well with some of the conversations we've had recently. Like we are getting more and more data products available for BSEC. And we're going to have more, like a lot of students, they either recently joined or will join BSEC. And this kind of tutorials and ebooks will be a nice way to kind of introduce the holdings that we have, give them some basic idea of how the data can be easily used and analyzed. And also the interactive dashboard is one option that we can offer to, for example, the community partners, and hopefully intuitive way to access some of the key observations like the weather station data, air quality data, for example. So these are the opportunities. And we recently had some conversation with MSC Live, thinking about how to leverage that feature in our upcoming efforts. Now let me switch back to my presentation. So this is just my second to last slide. We want to continue identifying the data and the software needs from BSEC researchers and community partners. As I mentioned, we plan to leverage MSC Lab's cloud-based computing resources to kind of develop data tutorials for training and education purposes. And also there was recently a mini proposal, IFL proposal funded, is to support, like we have 4 different IFLs, and each of us is using basically a slightly different ways to manage and organize data and how to make the data across different IFLs more kind of integrated. So that's one thing that we are going to look into in the near future. And lastly, I would encourage you to take the surveys. They're basically the same surveys as last year. Pretty the shorter URL here, so hopefully easier for you to remember. We still want to hear from you. Basically, you have something in mind, just let us know through the survey. So we'll put that in our radar. We'll definitely reach out to you and provide whatever help we can do to help you. And some of you apologize, and I have been chasing some of you to ask about your data. But hopefully we can work together to make sure that our products are openly available earlier. Thank you.
Yeah, Shane. Yeah, let's go. Thank you, Kirsten.
Question of the dashboard. Can those only live on MSD Live, or can they also be mirrored on like website or?
So MS Live offers the option to host the dashboard. It's still us to develop the dashboard, and once we have the dashboard hosted on MS Live, we can technically we can kind of embed that dashboard in other like websites.
Do you want to take the data survey like every year, or if we took it once last year and there's no changes, don't take it again until there are changes?
Yeah, so that's basically the same survey, because we consider, I mean, the data kind of holdings is kind of dynamic. If you do plan to make some changes or adjustment to what is put there, you can start a new entry into the survey. And if you have some new ideas coming up, feel free to put them in as well. But if you have already got it in and there's no change, you can just leave them. But if there's a status update, I think the easier way is to reach out to me or Chris, and we can kind of update our radar to reflect the status.
Sorry.
Good question. Could you give us a sense of, maybe I missed in the charts, what is the percentage of surveys taken by community members versus the scientists?
So that's a good question. Actually, we only have one entry for that category. We didn't get much input. We got total 21 inputs, and the one that falls into that category, the surveys and interviews, I'm pretty sure that's the Baltimore area survey, and that's the only one that represents this portion of the pie chart, the green portion. Did I address your question? Because we only had one entry, so it's hard to tell. I mean,
Okay.
Golden
The
had
survey
one
is not
entry.
really open to the community yet. Is that? I don't.
Oh,
Community members.
right.
Have
So
community members taken the survey?
good question, good question. No, right now, this surveys has been shared only within the BSEC investigation team. We
Okay.
have not. Um. That's a good question. I'd like to talk with probably the EPSC, is that the right term?
Yeah.
Yes, I'm not sure if I want to talk directly with our community partners. Maybe through the steering committee, coordinated through the steering committee is a better option. Possibly. But that's the conversation that we should
The
have.
purpose of this survey. Have a purpose, but it might be interesting to think about.
Yeah, even like the citizen science data that the community partners may contribute, that's a coordinated effort between BSEC and the community partners.
So I
So,
guess another way to ask the question would be, who is completing the citizen science data surveys?
that one, that entry, if I drill that down, that's, her first name is Katie. Clean, what's her last name?
Water.
Mhm.
Water.
But this entry was about the drone data that she was thinking of getting through some citizen science efforts. The drone data for selected areas of Baltimore, like the visible and thermal
So I guess-
measurement.
I guess my question is, how are we figuring out what software needs or data collection needs the communities have? How do we collect that information? And if that hasn't happened, what can the community engagement team do to help you gather that data? Would you like us to get involved or spearhead it? Or how do we, this is a big
Yeah.
missed
that-
opportunity.
That's a good question. Probably should have justified the main purpose of this survey is to have a good understanding of the science data and software products that the project aims to produce.
But isn't the project aimed to produce science that will
Right.
connect with community?
But yeah, that's true. As I mentioned earlier, I mean, even the citizen science projects and the community engagement, they are kind of coordinated through our equitable pathway steering committee and also Kalia and Derek's citizen science program. So we have representatives from the project, which can coordinate with the community partners if we want to collect feedback from the community partner. I'm not sure if I meant that.
I think the suggestion is that we should have a survey to the community to find out what their needs are to make the data accessible, right? We haven't done it.
Yeah, that's a good question.
Yes, my question is, I think it's going with what Tanya was saying, so we have the data, but I think what we need
Right.
to understand is what form the data needs to be in to be useful to the community. And so I think there's gonna be some coordination between the community and the data for feeding for that.
Well, if I'm hearing this right, it's not actually just that we need the data to be useful for the community, we need the community to be leadership position. in
Thank you.
projects. And so that means
Thank
you
you.
need to hear what their priorities are and they need to be in charge. And they're not, they haven't yet, there isn't yet any of that. Or I don't know, it's like, no, I don't wanna okay, so what are our community partners?
Yeah, they're telling us what they want. We need help in defining the dashboard or the way to make it accessible.
It seems urgent, really.
2 years have passed, 3 to go.
That's a great question.
I totally answer the fact that we are trying to work with the community to find the data that they want. And I'm not saying we're not there, but I'm having discussions nearly every week. People in the community finding out what they want. We don't get the answers of how to get there. But it's to say that we've done 2 years and we haven't.
No,
asked
I'm
the
not
community.
saying,
Well, that's what people
no,
just said.
no, I'm not saying that. I'm saying, where is the data on that conversation?
No, we don't have that.
Okay.
Yeah, that's a great question. So I'm very willing to talk with our like citizen science engagement program or EPSC, and through that kind of bridge with our community partners to collect the information. I think that's the way. I think this is probably a question bigger than this data support or software support.
I have a clarifying question. Is this particular platform and all of this specific to BSEC, or is this kind of like an outside collection of lots of different projects? Because BSEC was only one
Right.
category there.
Yeah,
Right.
so this
This
is,
isn't like a BSEC thing. This is like BSEC's like a part of this other thing.
yeah, this is not a basic thing. This is,
Yeah, I don't think that's your.
yeah, this is not just the BSEC thing. This is a platform that DOE has put a lot of resources and developing. And a lot of other DOE funded projects are leveraging this, and we kind of leverage this platform. So we don't have to reinvent the wheel.
And maybe another IFL is doing it, so maybe it would be good to reach out if other IFLs are using this platform to document community engagement.
Okay,
Other IFLs are not using this platform.
so we are the,
Your point is, good.
so we're the only IFL that uses this particular platform. Some other IFL, they are using a different platform like ESS Dive. And some other projects, they even like spend resources putting together their own data platform. So different IFLs are taking different approaches, but we're trying to avoid reinventing the wheel. So Peter,
So there are lots of these platforms and it creates some complications. So,
right?
so you have some of the Baltimore ecosystem study data sets here,
Mhm.
which are on the EDI. platform.
Right.
And they get automatically updated on the EDI. I'm not sure they're gonna get automatically updated here. And so we're gonna have to check back.
Yeah, that's another question. So we manually put those kind of metadata only records pointing to the EDI, but if EDI has a new version, we have to think about ways to update that.
All right, we should.
Thank
go
you.
on. And I messed up. I thought he had 30 minutes.
20 minutes, no, 10 minutes behind.
Sorry. So great question. I'd love to-
Discussion.
I can get us back to
My fault. Sorry.
I prepared the dance and we just won't do the dance. Just do the.
Now I need to find. Not that. This one?
Yeah.
So sorry, we're a little behind now. My bad.
And how do I advance?
Arrows.
Arrows?
Arrows.
Okay. All right, so hello, everyone. My name is Antonia Haji-Michael. I work at Penn State, and with Mike Bader, we lead together the Decision and Social Science team. So I'm gonna take a couple minutes to give you a theme overview, like you've heard from the other teams, and then I'll keep going and give you my talk before Ali presents on the work he's been doing with the heat crosscut, and then Raghav and Mike are going to give us an update on the Baltimore area survey. Okay, so first, why do we even need a decision and social science team in the first place? So a brief answer would be that if we are trying to address complex problems in the real world, we need to be thoughtful about values that we take into account, objectives that we consider, uncertainties that we model, and all these things. And to do these things properly, we need frameworks, decision analysis frameworks to guide that effort. And at the same time, we need to be mindful of the values of the stakeholders or the decision makers. So what our team has been up to is falling under two broad umbrellas. The first one is to use decision analytic frameworks to guide the analysis of candidate adaptation pathways or adaptation solutions to key problems in the city. And the second broad goal is to try and incorporate residents' perceptions and values into a process of collaborative knowledge co-creation. So just a high-level overview of what we've been doing. So in the past, you might remember we had done this decision framing exercise, what people call the XLRM. So we're using those now, and we're combining them with information that the community engagement team, which is a different team from us, they led an effort last fall. They collected a lot of input from the community, and they did a great job summarizing it. So we're using that and the framing that the scientists put together to kind of guide the subsequent metric selection. So, and the reason we need to do this is because people care about things, but it's not really easy to measure or model everything. So we kind of need to narrow it down to actionable. Then Mike has been spending a lot of time submitting an IRB application with the community engagement team. And then there's also the first Baltimore area survey out. That's not a core BSEC thing, but it's relevant to BSEC as it contains a lot of relevant data, this year, going past. And then we'll also work to incorporate some of BSEC research questions into future versions of the Baltimore area survey. Yes, I wonder. We presented a bunch of times and we are working with theirs. Okay, so currently what we're doing is Ali is going to talk about this effort he's been leading on updating the prior city heat analysis. This was the multi-objective search for solutions for adaptation for heat. So he's working on a neighborhood level framing. Then Ava, we heard from this morning, is doing a similar thing on flooding. So again, a multi-objective analysis. And then we're also developing these materials for the metric refinement sessions that we're planning to hold soon, starting with the heat one. I think I'll keep it brief so we'll catch up. You see. Okay, so now I'm going to give you my spiel. So that was the theme update, and I'm happy to take questions about it. Then I'll give you my sort of views on how we're doing these things and how I think BSEC could incorporate some of the state of the art in this world. So we've used the term wicked problems a couple times. I just want to remind or define the term in case people are not aware of what it is. It's kind of like an old school term and we don't really say it anymore. But what it means is it addresses problems or it captures problems that are not well bounded. So these are problems that might not have clear root causes or clear end outcomes. They might be framed differently by different groups of people or different stakeholders. And they also typically have very significant uncertainties that we're still unclear about. And typically, but not always, they exhibit a lot of nonlinearities and other complexities that are hard to predict. So in the decision analysis world, this makes it, this kind of nature of a problem, it's difficult because of sort of two dimensions. First, we have this uncertainty over consequences. So we have uncertainty over what might happen, say in the future climate change, or uncertainty over an action. Say I implement a policy and I have a guess over how well it will work, but I'm not certain. So we have that axis of uncertainty. And then we also have uncertainty over objectives. So what I mean there is uncertainty over values. And that's typically the case for multiple groups of people. So when you have multiple values at play, but it also happens with individual values. We maybe think that we value something, but we also value other things that we don't realize. So this makes it complicated because when I'm fairly certain about my values and my objectives, and I'm also fairly certain about the consequences, It's an easy problem. It's a computational problem. It's a quantitative cost-benefit analysis on a spreadsheet or something. It's an easy answer. Problems come when we do have more uncertainty. So when I have uncertainty over future outcomes, maybe, I need to bring in human judgment, usually in the form of an expert, a scientist that can tell me what's more likely than something else. And then when I have uncertainty over values, because maybe there's many stakeholders, that's when bargaining or negotiation has to take place to figure out what we want to do. But when we have both of these things, the author of this chapter suggested inspiration is the solution, which I'm not sure if it's the right word for it, but I would argue that he's right in that computation is probably not sufficient, but I think we can do better than inspiration. So what can we do? Well, to know what we can do, sorry, I'm gonna have to check my time, is we have to first recognize the problem. So the problem is that people are often overconfident about their ability to make good decisions. They make decisions or take actions that are inconsistent with their long-term interests or their values. They have a hard time acknowledging trade-offs, especially internal trade-offs, and they might employ decision-making heuristics that are inappropriate for the situation that they're struggling with. And these are findings from behavioral economics, behavioral sciences, that we know these things from them. So this exists in the context of also a world that's very heterogeneous and diverse, and also has significant uncertainties. So we struggle to make decisions on our own, but are also in the context of having diverse priorities that we need to consider, and also irreducible uncertainties that we need to deal with. So what these things mean is that we have to use some sort of decision support tool or analysis or something that help us overcome these limitations that we have as humans. But at the same time, traditional approaches that work for simple problems will fail for complex real world problems. So what we have to do instead is use decision analytic frameworks that kind of help us plan in this case. And the way we kind of go about this in my field, it really requires a shift in perspective from a perspective of predict and act to a perspective of explore and design adaptation or figure out what the adaptation could be. So this is really a shift in how we use models. So typically in a lot of traditional natural sciences or engineering, we use models in a sort of consolidative fashion where we put together the best available knowledge, we package it in a model, and we use it to predict things as if it's the most ideal representation of the world. So we understand they're limited, but we kind of use it to predict things. So it's a form of deductive reasoning. But in this exploratory approach, we want to map assumptions to consequences and explore what happens. What if I change my assumptions? What are the new consequences that might be at play? And that's it's a form of inductive reasoning. It's more exploratory to see patterns and discover what matters. But this is really enabled. We weren't able to do this sort of work 30 years ago because we were limited by our computational capacities. We're limited by our ability to visualize high-dimensional data, all these things. But now we have these things, and we also have powerful classification algorithms from statistics or from machine learning, and we also have powerful optimization algorithms from mathematics and artificial intelligence. So we can move to this more exploratory mode that's more appropriate for the complex problems that we are working with. Okay, so what does this look like practically? What it looks like is that we want to consider a multiplicity of plausible futures, so a large number of plausible futures. We also want to consider a large number of potential solutions. And we typically combine them in some sort of model, a representation of a system, to create an ensemble of outcomes, so a large number of potential outcomes. And through these outcomes, we try and identify solutions that I highlight are not optimal, but they're satisfactory. And the reason we don't want optimal and we don't care for optimal is because we recognize this is highly uncertain and this is highly uncertain. So optimality is just an illusion, yeah? So we want something that's good enough. And then out of this, we have other tools that I won't be talking about today, but that allow us to refine what uncertainties in the future I consider and what actions I consider. So we want to refine this through an iterative process. Most importantly, we use the computer or our models to facilitate discourse between humans. We're not using the computer to tell us what to do. And the analysis is not prescriptive. It's just a tool through which we navigate and explore and negotiate solutions. That's the idea. How much time do I have? Okay, plenty of time. Okay, so if you heard about this XLRM thing, it really is a way that starts to get people thinking about these things. So the uncertainties, the things I can do about it, my model or my representations, and how I measure it. That's what that XLRM thing is all about. In practice, the way we do it, like in the work I do, is use different tools to play around with this, to figure out what's the best way of exploring, you know, there are better algorithms for doing it. And typically what we do is we use sort of 3 classes of approaches, and I'll tell you how we do them in BSEC. So we have either exploration tools, things like sampling, so I just sample percentage change in temperature or change in precipitation, I sample the change. I can search through optimization algorithms, so I can search for values that do something. And I could also pre-specify. So in a lot of the climate adaptation literature, people pre-specify scenarios. So that's what the SSPs are. So summary, pre-specified summary. Or in a lot of public planning, people pre-specify solutions. Yeah, so we use a small set to make it easy. But I think we don't need to specify. I think we can be smarter. Okay, so in our work in BSEC, in the work Ali is going to present and what Ava is working on, we really are using research tools. So we're using multi-objective optimization to search for solutions, and we evaluate them under an ensemble of plausible futures. That's what we're doing. But we are also trying to consider the timing of things. So I could have a potential solution, say action B, which is plan more of this or build more of this. But there's a very important question of timing, because these things cost money. And you don't want to build something when you don't need it. You don't want to build a huge cooling center when you don't need it anymore. You just have it there now. Yeah, so the timing, what's triggering the action is a very important question. And this also creates a path dependency, because what if I make the wrong decision and now I'm stuck financing this project I built 10 years ago, or I'm stuck having to accelerate investment because now it's too messy. But okay, the last couple of things I want to say. So this is what we're doing so far in BSEC. The state of the art in this discipline is also looking at a couple other things. We're very concerned about what's called a lock-in effect. So things where we take actions that kind of limit us later. And it's often tied with this idea of a window of opportunity. And if you read the latest IPCC report on the impacts of adaptation, there was a lot of language around the windows of opportunity. And a lot of language around pathways, the use of pathways that broaden the window of opportunity later or narrow it. So you can do that. You cannot do that much. You're kind of stuck to a warming condition, or you're kind of stuck to those impacts. And then we also want to think about this desirability through time. So maybe the current government likes this solution, but what about the next one? Maybe they don't like it. So what if we can identify low regret options that, like, even if we change our opinions or if we change our projections, they're still kind of okay. So there's a lot of sophisticated tools we can use there. Okay, I think I have one more idea. And then the other thing we talk about a lot lately in this work is this idea of storylines as a way of enhancing communication and facilitating the process. So as you can imagine, when we do this, a typical experiment of mine is maybe 500,000 simulations, sometimes 1,000,000 simulations. That's very hard for most people to think about and make a decision. So we're trying to use tools like storylines that try and take this large ensemble and make it something that's a little more tangible for a regular person to negotiate and decide what they want to do. So I don't think I have a concluding slide. Okay, so I think that some of these tools I think are very neat ideas. This is where the state of the art is in this field, and we have these tools to use them. We just need time and more graduate students. Yeah, no, just leave it like that.
Here, this approach often allow you to focus on where you need to build adaptive capacity or resilience. So you can talk about these plausible features and the options, but then people's capacity to take advantage of those options. And it seems like this would be very useful for saying, here are the vulnerabilities, here are the opportunities for increasing adaptive capacity or the other term of the resilience. So does that kind of thinking play into this?
Yes, because especially the trigger idea, because not every solution is something, maybe I cannot do everything right now. But maybe it's something very expensive, will cost a lot of money, and I just want to see, do I really need it? Or like, where is the best place to put it, and when is the best place to put it? So these kind of icons in these figures typically denote a point where it's a trigger for a new action. Most importantly, you could also change. You switch your pathway.
So you get a couple more questions. Kalia, Simon.
Yeah, so I think today was the first time that I actually understood what you all. are
Oh, what
doing.
these guys are doing now.
Yeah.
Yeah.
So on the stage, so I would definitely like to connect to these. I know I've asked a couple of times, but I think we were having to wait for the IRB, but how we can utilize the Excel RM in the community engagement.
Yeah.
If that's a tool that you can use, and if you all can help with, I know, and I was talking earlier about, you know, having, and I mentioned it in my presentation, actually having pre and post surveys, and that was just something that I had, that I wanted to, that was.
Yes, definitely. And just if I can show, so this, what I was showing here, so we had the scientists brainstorm this, but we have a lot of insight from what the community engagement team measured last fall. And these are meant to become these metrics. It has to go in a model. Yeah, some of these things are hard to put in a model. So if somebody says, I care about justice, it's very hard for me to write an equation where you maximize justice. But there's other things that I can't quantify. It's like comfort in the summer, and it's a temperature. So which of these things, and like, how can we work together with what they've said and what we can do to actually measure? That's the idea. Yes.
Fantastic presentation. Always love XLRM. Wondering,
Yeah.
what's the role of history? Because there's a very important phrase in the very beginning of your presentation about unintended consequences.
Yeah.
So what is the role of history, figuring out what were the unintended
legacies.
consequences of certain
In the
decisions,
past.
and who is the expert on sharing those unintended consequences, so that moving forward, we learn from the past as opposed to constantly blindly moving forward.
It's a very good point. I have no idea. I don't know how. It's a computational tool. So I don't know how you'd have to engage the right people. Maybe it's a part of a process. So this tool wouldn't tell you anything like that. But it's a procedural question. It has to do with who's in the room when they frame maybe the relationships, or when we frame what we measure. But I cannot do it. Did I disappoint you?
No, you didn't, because you were at least honest. You were at least honest. You need to engage, community engagement.
Yeah, exactly. I cannot do
Move
that.
forward.
Yeah, it's
So
not.
all the feedback that I'm getting, I would give to you all to put into this. framework.
But I cannot, there's things that we cannot model. These are just models. These are just numbers. A lot of it is procedure. It's who's in the room, who gets to say what this is. And we need to lean on you to do that, right? But I cannot, I cannot quantify legacy effects of bad decisions. I'm also not the modeler. These people are. I'm the person that does this.
Thank you, Antonio.
Thanks. Do I go to the back?
All right, Ali is up next, and I think he's going to present online. Correct, Ali?
Yeah, can you hear me?
Yes, we can. Are you
going
gonna share your
to
screen?
share my screen? Yes.
There you go. You're on.
All right. Okay. Okay, so hi everyone. My name is Ali. I'm a PhD student here at Hopkins. And as you can see here, the topic of the talk is going to be about city heat. So you've all heard about city heat before, ever since P6 started. And I've been working with it for the past year or so. And I want to talk about how the model works in general. And oh, I did not. I just realized. All right. How the model works in general and some of the results we can expect to get from it. All right. So what is city heat? It's basically an urban adaptation tool that provides policies and strategies for planning, for strategies at planning district level to counter the effects of urban heat waves. And it does this while considering all these uncertainties that we can have inside the city. It was developed here at Hopkins a few years ago by Raishi, who was a PhD student here. And it was under a project called Marissa. So in general, what this model tries to do is to reduce heat-related mortality and increase equity while spending money in a reasonable manner. It uses 4 different adaptation strategies. You can see here planting trees, implementing cool roofs, implementing cool pavements, and installing cooling centers in different regions of the city. As I mentioned before, there are several different uncertainties including the model, which can include things like actual effects of mitigation strategies, the rate of temperature increase, the relationship between mortality, heat-related mortality and temperature and stuff like that. The resolution of the model was at planning district level for Baltimore. I'll talk a little more about that later on. And also the model was, the decision-making process inside the model was dynamic through time with regards to the changes in the environment. And I'll explain a little more about that later too. All right, so let's see how this model actually works. It's a pretty straightforward optimization simulation framework. What we have on the left here are the inputs of the model, and we call them policy functions. These are basically environment-reliant plans for implementing the strategies in each of our region. We evaluate these policies under a quite big number of scenarios that are realizations of the uncertain parameters that we had. Here you see that we had like 17 uncertain parameters. And at the end, we find the values for our 5 objectives. So you see on the right, the objectives, the 5 objective functions that we had. And this whole process basically gets repeated numerous times inside a multi-objective evolutionary algorithm called Borg until like we find our policy plans and the objectives that they have. All right, so before going into the results, I want to explain what these policy functions dimensions are. So they are 3-parameter logistic functions. We basically use them to reduce the number of decision variables by eliminating the time dimension. And then instead of optimizing for 50 decision variables for each of the strategies, because we had 50 years and 50 time steps, we only need to optimize for 3, for A, B, and D, as you can see here in the formula. And this would reduce the number of decision variables that we had in the model from around 5,000 to around 100, which makes finding the solutions much easier. And You can see here at the bottom how they actually look like. So basically, based on the number of heat wave days that we can have in like different regions in previous years, what we do is basically we decide on what to do in terms of implementing the strategies based on like the capacity that we have, how much of the land we are gonna assign to planting trees, or how much are we gonna like do cool pavements and cool roofs and so on and so forth. All right. Okay. So some of the changes that applied to the model, I updated the temperature projections to include a wider range of variations. The model is now looking at 50 years of plans instead of 20, which it was doing before, to evaluate the long-term effects of the adaptation pathways. I also implemented budget policies and yearly cost caps by altering the policy functions so we can have more reasonable spending plans because of the nature of mitigation policies. The model would naturally lean towards investing most of the budget in the first few years if we don't use these cost caps, yearly cost caps, or budget policies. Another thing was that we changed the scope of the model from planning district to neighborhood level, or CSAs, community statistical areas, which are actually different than neighborhoods. So this would first capture the variations in the statistics of these regions much better, and also makes the presentations of the details of each region much more meaningful, especially if we are planning to present some of the pathways or the details of the results to the community members at some point. All right. So what would the result of a model like this look like? So running this optimization under these criteria and several other criteria would give us a solution space that looks like this. So this is called the parallel coordinate plot, and it shows the trade-offs between different solutions in our 5 different objectives. So you can see the direction of preference. So basically, it's pointing towards where we want our objectives to be, right? We want to spend the lowest amount of money while we want to have the highest amount of heat-related mortality reduction. And each of these lines are showing a different adaptive pathway, and they're what we call non-dominated solutions, which means that you can find another solution that is performing better than them in all 5 objectives. So most of these values of the objectives are self-explanatory, but how do we define equity, which is shown in the middle part of the plot, is by basically finding the maximum heat-related mortality rate difference between neighborhoods throughout the years and try to minimize that. So basically, we are trying to minimize discrepancy in heat-related mortality between different neighborhoods. We can also see the trade-offs more clearly here. So these plots show the trade-offs between pairs of objectives. On the left, you can see the trade-off between equity and mortality, and on the right, the trade-offs between cost of plans and its corresponding mortality reduction. And we can find like some interesting results here. For example, like reducing each heat-related death is found to cost between $0.5 to $1.9 million, which is like the cost of saving a life, basically. So each of these solutions with these trade-offs can offer like different things, and we can see all of the different metrics for each of these solutions. So here I just chose one of the middle cost solutions, and you can see the details of it at the top, and on the left you can see how the investment required for the specific plan changes over time for each of these strategies, for planting trees, for implementing cool roofs, and so on throughout the years, and how much of the money we are actually assigning to each of these strategies. And we can also get these kind of maps for neighborhoods for different metrics. Here I'm showing the resulting temperature mitigation from using the strategies at the end of our simulation period compared to not having the strategies. And on the right, you can see the total mortality, heat-related mortality reduction as a result of having these strategies. Also, I have to add that all of these results are, as I said, we had like a huge number of scenarios. We had 6,000 scenarios. These are averaged over all the scenarios and like all the different outcomes or the different situations that we can have. Um,
Ali,
yes,
got about a minute.
sorry.
You have about a minute.
All right, all right. All right. It's the end of it. All right. We can also look at, for example, how much money the city can expect to spend in different years for specific strategies in different neighborhoods. Here, I just cherry picked a few of the neighborhoods from different areas of the city, and you can see throughout the years, in different years, in each of these different neighborhoods, how much the city can, like, for example, in this specific solution, plan to spend money on. And here are some of the next steps for the model, and thanks for listening.
All right, thank you. Question?
That's a good question.
One question, yes, Rama.
So, Al, you mentioned that you would choose 3 time steps out of all the possible time steps, like for 50 or 15 time steps. How do you choose those 3 time steps?
Oh, maybe I didn't explain properly. So it's not on choosing the 50 different time steps. We are basically like eliminating the concept of time step, right? So for the 50 time step, for the all 50 time steps that we have, we basically give like a kind of a function. So in each time step, based on the situations that we have in the neighborhood, in the environment, like we had like in previous years. For example, here the number of heat wave days that we had in previous years. Then we decide how to plan, how to like act according to that strategy. Basically, it's basically a parameterization. So like we optimize for just 3 variables, which are not time, which are just like how we define these functions, these logistic functions. So we don't have to just include time inside the optimization.
I see. Thank you.
Thank you, Ali. We should move on to Mike.
All right.
And let me make sure that I have the right file up. Which one is it now? It's, there we are. Yeah, no, we're not doing it from Google Drive. So I downloaded them all here. So, hi everyone. Oops, I got to share, but go ahead.
I'm Mike Bader. You probably heard about some bet that I made with Ben. That's what I'm famous for now, apparently. So I am really excited to introduce some of our work we've done on the Baltimore area survey, which Antonio mentioned, and to present it is actually one of our all-star undergraduate research assistants on the project here at Hopkins, Raghav, who's going to talk us through some of the results, and then we're happy to answer questions afterwards.
Thank you so much, Mike. Hi, everyone. My name is Raghav. I'm an undergraduate research assistant working on the Baltimore area survey. I started working with the team last May, and throughout the course of the year, we've been trying to, develop sort of a lot of analyses that we would like to share with you today. One of them being the climate change assessments that Baltimore area residents want to make about their city. So thank you to Mike and Mac for helping me for the last year, and I'm really excited to present this to you today. So just to give you an overview of what the Baltimore area survey is, it's an annual survey representative of the residents of both Baltimore City and Baltimore County. And we hope to use a lot of this data that we collect to help people, businesses, local institutions, governments, really anyone who wants access to this data to make better decisions, to learn about how people feel about a multitude of factors in the city. To give you a little more about how we conducted the survey, so this is 2023, so we put it in last summer. It was mailed to 10,000 addresses across both the city and the county, and we had about a 13% response rate. So I think 1,350-ish results, just over 800 in the city and just over 500 in the county. And we did weight the survey both on a sample and post stratification basis, just to make it more representative of the entire Baltimore area. And we did work with a margin of error. So of like the 105 questions that we did ask people who filled out the survey, one of the ones that I was really excited about when I heard about it was this question about how people feel or how concerned they are about harm that climate change may inflict on them in the course of their lifetime. So we gave them 4 options, going from very concerned to not at all concerned, which we can also use in sort of a binary concerned or not concerned fashion, which we'll see in the analysis going forward. So just talking a little bit about results now. And just again, these are not sort of causal inferences in any way. They're more so, descriptive analyses of things that I really just found interesting about my city. So this an overall like an estimate on how people are concerned about climate harm in Baltimore. We see that 75% of people are at least somewhat concerned by climate change and harm from it, which to me is very reassuring. But about 40% of them are very concerned, 33 somewhat concerned, and less than 1 in 7 not at all concerned. So it's definitely an issue for Baltimore area residents. Now, coming to our first cross stab that I want to, expand on is race. I think everyone in this room knows everything there is to know about racial discrimination in Baltimore, and past, present, future, it's what it is. So we are trying to look at how, race not really causes different concerns, but how concern may be, distributed amongst races. So we see like pretty off the bat that at least on this side of the screen, white residents in the Baltimore area are 3 times as likely as Black residents to be not at all concerned. And just pivoting to this binary concern variable, when you club them together, you see that about 80% of Black residents are at least somewhat concerned compared to 67% white residents. So we really have a lot of hypotheses that we are trying to float, trying to understand why this is the case. But something that I'm particularly leaning towards too is that Black residents, given past and contemporary policy and racism, may find it harder to trust institutions like governments or even local organizations to make decisions that will help them through harm through climate change. Or they're just not convinced that they will be helped or looked after in response to climate disasters. And which is one of many hypotheses that we're working with when it comes to race. So talking a little bit about income and the joint distribution of race and income, we see, pretty startling statistic for me at least is wealthier Black residents are actually the most likely of all the categories that we have to be concerned about harm from climate change. Forget just, comparing them to wealthy white residents, but just overall, which, is a pretty startling statistic and something that I would really love to explore a lot more on. And one of the ways that I'm going to try to do that with the team is through this is just again a binary understanding of Black residents and white residents like concern levels. We use 70,000 as the median income of the area. So really just pivoting to a spatial analysis where we want to include, income and race is obviously one thing, but a lot of different factors when we do a spatial analysis. Now, the reason why I think spatial analysis is really important for something like climate change is because it's a highly geographic thing as well. And given, all the history of Baltimore, different areas will respond and react differently to climate harm and harm from climate change. So we can see over here, we use PUMAs, which are public usage microdata areas that the Census Bureau actually creates. So we have about 12 PUMAs in the Baltimore area, 5 in the city and 7 in the county, where the Census Bureau actually, reaches out to over 100,000 residents to get a lot of important information. So we just use that as like our geospatial field to play with and see what results we come up with. So you can see right off the bat that Baltimore City is actually a lot more concerned than Baltimore County when it comes to climate harm. And this is pretty interesting just to me, but I hope it is to you as well. This North Central Baltimore is actually where Homewood is, and that is the most concerned PUMA of all about climate harm. So about 88% of residents in North Central Baltimore are concerned. And so again, just really looking at why this may be the case, or how we can connect things like race and income to geospatial analysis, we can see that although we have our notions about how different, racial groups may react to things like climate change, I think the income slide really taught me that even within races, so intra-racial differences do exist. And it can be based on where someone lives. Maybe it's just hotter where they are. I think a lot of work that BSEC has done is trying to understand on a neighborhood basis why it's hotter in some places. And so really looking at that, looking at why wealthy Black Baltimore area residents may differ from their opinions from wealthy white Baltimore area residents may come down to a geographic analysis. So there's a lot of scope for us to use this, and I'm really excited to keep working with the data that we have. So just to sum up, This is some high level like results. About 3 in 4 Baltimore area residents are at least somewhat concerned with harm from climate change. And wealthy Black Baltimore residents are especially likely to be concerned, not just compared to wealthy white residents, but across different races and income levels as well. Thank you. That was the first question. Take any questions?
Thank you. I'm wondering if you could share with us the zip codes. Did you map the zip codes of where the forms went?
Yes, so we do have address level data of the respondents. So that's actually the extent of the personal information that we have of a respondent. So something that came to me really late, even yesterday, actually, when I was talking to a lot of people over here, is building on what someone like what Ali did, where he condensed it down from just the Pumas to either census level or neighborhood level analyses. That is something that we can do, and I'm pivoting towards doing that based on like address level information.
It'd be
Yeah,
great to
so-
map the survey.
So, well, yeah, so one of the things, the reason we didn't have, and I promised Raghav that I wouldn't pitch all of the questions to him, since he's brave enough to get up here. One of the reasons we didn't do that is the N, as you get into smaller geographic units, you can imagine the N goes down, so reliability of the estimates also goes down, right? So if you only have, so we have 1,300 people distributed across the entire area. There's some zip codes or census tracts that have only 10 people, and so it can show very wide differences because the sampling error within any individual zip code can be drastically larger. And so we wanted to get something that was large enough to have large enough samples that the estimates within the geographic areas were reliable, which is why we relied on Puma. That being said, we do have, as Raghav said, we have point level data. We actually have address level data inside Copy. And I'll talk much more about IRB in a minute, but if anyone else wants to, I'll probably also get address level data. And so we can do things like use geostatistical interpolation methods to actually create a surface of concern across the city. So that's some of what we hope to do, and then integrate with what Ali's doing and others. So
Even before the analytical part, I'm just concerned that it should be good to see.
But
who
yes,
sends
I
the
understand that, but
forms.
the problem is that if you only have a small sample size, you don't know if it's the sample you do, like any other sample, right? If you have a sample of 10, that's not nearly as good as a sample of 100. So if we show a sample of 10, it shows a very large, towards one pole or the other. We don't know if that's sampling variation, that we just happen to pull 10 people who are very concerned or very not concerned. And so we want to make sure the sample size within each geographic unit is large enough.
So maybe you're
Just
not,
going back with the sample return.
that's what I'm asking.
Oh, yeah, we have
I'm
that.
not
So,
asking for the analysis, I'm saying
Asking for
just
return.
the form,
Oh.
whoever returned the form, if we can get the zip code map, that will tell us.
I can
Who
tell you
is
exactly where
at
it is.
least replying to the form.
So yeah, we have that map. I don't have it in this
That's great,
presentation. Yeah, we actually have it by track level, so even smaller than the code.
That will tell a lot, that will tell a different story.
Yeah, I mean, one of the other things we've also done, in addition to the sample, is all these are weighted to try to get back to the representative by race, education, Puma, homeownership, gender. I think that's it.
Sure, question from Larry. Very nice presentation. This is based on people's expectation. Once you have the address data, can you also make it conditional on people's experience? So if we can map out extent of large storm surges or floods or even heat, can you do it retrospectively in terms of what their experience of climate related hazard?
Yep, and one of the questions we have on the survey is how long they lived in the neighborhood. So we would actually know, so if someone moved in this year, so we know if they were different. So we interacted not only by the experience in the neighborhood, but also by how long they've lived there.
Like 3 times IRB. Maybe it's time.
Oh, there. Oh, no, I'm talking about in the last.
Oh, that's later. All right, so we can take one more question. Ben.
How does this compare to other cities or other places in general?
So this is a question we just used on it, so we don't know, so. I need the data that I know is the best on this is the Yale data, they don't ask exactly the same questions, that would be good to look at. I should mention one thing, just real quick, I should delay it so I get so I win the bet, but. Sandbag. But one thing I did want to mention is starting this summer, so the 2024 survey will go in the field very soon, hopefully. We've finished that. There are a couple questions from BSEC groups that are put on it, but starting this summer for the 2025 survey, so the survey is gonna go in the field next year. BSEC is paid for a decent chunk of the questions that go on that survey. So if there's ways in which either through the crosscuts or some of your individual themes that would be useful to have data. I'm not promising all the questions will get on, we have a limited number, but it is something I'm gonna start this summer to make sure that we have the right questions and we may coordinate across the large project to figure out which questions go on, but that will be happening starting this summer. Let's call it coffee break and let's come back in at 3:35, 5 minutes later than planned, because I messed up. All right, thank you.
Yeah.
Couple minutes from coffee, sorry. All right, Scott's up first with the greenhouse gas group.
Oh, and can you flag me down if I'm running out of time here? Ava, okay, awesome.
We'll give you the warning sounds.
Okay. Great, so in the next few minutes, I'm gonna give kind of a high-level overview of some of the greenhouse gas research that's been happening under BSEC, and then after my presentation, well, actually, I'll talk in a minute about what's gonna happen after this. And so thanks to the folks who contributed figures to the slides here. So before I dive in and talk about specific things that folks are working on, I want to kind of zoom out and talk about some of the high-level goals of the greenhouse gas group. Number one, folks are really interested in better understanding the sources of greenhouse gas emissions across the city. We want to understand the interplay between infrastructure and emissions. So how does building design affect emissions? There we go. If we go back. Okay, cool. How can we improve biophysical models of natural fluxes? And this is something also that the vegetation group talked about yesterday. Can we identify equitable and effective pathways to reduce emissions? And then what are the impacts of proposed emissions measures going to be under climate change? So ultimately, just a second. I think one challenge that the greenhouse group is really thinking a lot about is how do we connect observations that we collect across different spatial scales, and how do we really tie what we see sort of at the plot scale to what's happening at the city level. So ultimately, we want to know how much greenhouse gases are being emitted in Baltimore or absorbed by the biosphere across Baltimore. And over here on the right is an emissions inventory that Dylan Gata, a PhD student, put together for Baltimore. And you can see emissions in 2007, 17, 18, 19, and 20. So emissions have gone down a bit, but not dramatically so across the city. But of course, these emissions are going to vary a lot from one building to another, and fluxes are going to vary from one plant functional type or one neighborhood to another from the biosphere. And so, you know, understanding these processes or fluxes at small scale is arguably really important to understanding what's happening at the big scale. And so, like I mentioned, one theme I think among this group is, you know, that we've got different observations that really span from the meter scale up to the entire city scale. And I think kind of a goal or challenge is for us to connect these different scales together. And here are some observations that Pete DeCarlo's group took of methane across the Baltimore. And I think this really kind of highlights that heterogeneity. You know, most of this methane is coming from leaks from natural gas infrastructure. And you can see that, you know, in aggregate, we want to know how leaky infrastructure is across the city. But there's a lot of heterogeneity in these leaks from one block to another or one street to another. So let me dive in a little bit more and kind of give some highlights of what different folks within BSEC are doing on greenhouse gases. And I'm going to go quickly through a few of the slides that have already been covered by other teams. And this sort of here is one of them. Folks within the vegetation group that are kind of crossed with the greenhouse gas group
folks like Peter and John Duncan are looking at measurements of greenhouse gases that were originally started as part of the Baltimore ecosystem study and now being continued as part of BSEC. And I think Peter might have talked about this yesterday that, for a while that it looked like methane fluxes were increasing from vegetation, or that uptake was decreasing, but now that's sort of changed over time, or if you look at the time series after 2015, that the curve is starting to change directions. Another thing, and I'll go through this briefly because it was mentioned before, Ben Allsweet is going to give a talk as part of this session here, detailing some of the observations that they've been taking using what are called eddy flux observations to try to estimate greenhouse gas fluxes. In this case, this is from Clifton Park here. And this plot shows greenhouse gas fluxes that are coming from a turf grass site. And so the goal here is to characterize this kind of turf grass area in Clifton Park, but then kind of in the long term, we want to know what different plant functional types are doing in terms of greenhouse gas fluxes. And I think this plot, I think Megan highlighted this plot in the vegetation and soils talk yesterday, so I'm not going to spend a lot of time here, and I'll let Ben talk more about this in a few minutes. And then the next step that Ben and Ken Davis's work group more broadly are working on is to set up eddy flux sites across Baltimore. So you can see here's an example of one of the towers that's being considered. These are probably going to be put on 2 different telecommunications towers in Baltimore. And you guys can correct me if I'm getting this right. I think since these are going to be a little bit higher up than that turf grass site that we talked about, we might get a slightly larger footprint or a slightly larger kind of view of greenhouse gas, significantly larger view of greenhouse gas fluxes.
20 times the size.
Yeah. And so I think kind of a goal here is to help highlight some of the neighborhood level heterogeneity and greenhouse gas fluxes in different parts of the city. And so again, this kind of goes back to this theme of connecting different spatial scales, right? Like looking at a turf grass site and then kind of zooming out and then starting to look at larger and larger scales across the city. Ben Nault talked about this a little bit earlier, that Ben and Pete's group have put together this mobile laboratory. So this mobile laboratory also looks like a giant white kidnapper van here in the photo. This is next to the garage in Remington. And here are some of the instruments.
This is an Amazon van, not
a kidnapper van, okay, an Amazon van. And these are sort of what some of the instruments look like. Usually I'm not allowed to come anywhere close to any of this sort of stuff lest I break it, but I trust that Ben and Pete know how to operate this stuff. And so they're using it to measure greenhouse gases or planning to criteria air pollutants and air toxins across the city. And again, Ben talked about this a little bit in his talk here. Here is showing a time series of CO2 and methane across many days. And then this is showing just a time slice from a particular day, CO2 on the top and methane on the bottom. And you can see, particularly with methane, that there are some spikes in the methane observations. And I think we'd really like to know what's causing that, presumably leaks that are happening from natural gas systems somewhere. And it would be nice to know where those are and so on and so forth. And then Kirsten touched briefly on this earlier. Later, Chulin and Bowen are going to talk about some of the work we're doing with a low-cost air monitoring network that Kirsten talked about before, specifically looking at methane and trying to calibrate the low-cost methane data and learn something about methane emissions from the city. And then I'm going to leave this for Bowen and Chulin to talk about. So on the modeling side, folks from Ken Davis's group have also been trying to model vegetation at large scales across the city. I think Dan yesterday talked a little bit about the ELM model, and this is some simulations that Jason Hornet put together here, looking at CO2 sources and sinks from the biosphere across the city. And I think one thing that is amazing about these model simulations, this model here is called VPRM, is the spatial resolution. So this is Clifton Park here, I believe, and you can see kind of a very fine resolution, a prediction of what we think those sources and sinks are. So I think something like this is one of these really important steps that helps us connect the small scale with the large scale across the city. Okay, so next steps, in terms of human caused emissions, going back to methane, we really want to understand where and why is methane being emitted across the city. In terms of the biosphere, going back to the work that Ken Davis's group is looking at, you're doing,
We want to understand how CO2 fluxes from vegetation differ in different neighborhoods. And then lastly, we're going to have several talks in this greenhouse gas session here that are specifically going to focus in on buildings and looking at how can building retrofits and how can increased density help us to cut greenhouse gas emissions across the city. So that's all I've got, and hopefully that's kind of a good overview and an introduction to some of the talks that are to come. Great.
Question, time for one.
All right, we can save it all for the individual presentations. And it's all next.
Stick around just to make sure the presentation, I uploaded it for them, so.
Yeah,
Do you need me to go to main PC?
yes, leave it there if you would.
Somehow it just keeps wanting to switch itself.
Oh, that's weird.
Yeah,
Okay, so this I don't think I need anymore.
yeah.
And
Yeah, yep, there we go. Cool. I think this file's a little bit bigger, so it may take a minute.
Then we downloaded this one.
Yeah.
All right. You're up and running.
Cool.
Hi, my name is Chulun Li, and I'm a PhD student advised by Professor Kirsten Kohler and Professor Scott Miller.
And good afternoon, everyone. My name is Bowen, and I'm an undergrad here at Hopkins, majoring in environmental science with a minor in computer science.
So today we are going to talk about methane monitoring network in Baltimore, as Kirsten covered search in the morning. We will focus more on our statistical in-field calibration model.
So before we get into our research, let's talk about why we care about methane. So methane is much less abundant than CO2, but it has a much greater heat trapping ability than CO2 in a 20-year time frame. So addressing the methane emissions right now would enable us to achieve climate stabilization much faster. So buying us valuable time to address the longer term greenhouse gas emissions. And our project directly aligns with the local and global climate goals by making methane monitoring much more accessible and affordable for everyone. So what are some of the challenges in methane monitoring, especially in an urban setting? Well, first of it is that methane emissions in urban settings like Baltimore comes from diverse and complex emission sources, from natural gas and infrastructure leakage to landfills, from wastewater treatment to residential usage. This complex source really makes the whole urban landscape a complex mosaic of different methane hotspots. Another problem in the methane monitoring in the urban setting is that traditional bottom-up inventory approaches tend to underestimate the real emissions due to its reliance on incomplete or outdated data and assumptions. So on the left here, you can see here is a study done in 2018, and it compares a top-down inventory with a traditional bottom-up inventory. And a top-down approach can provide a more accurate estimate by directly measuring the atmospheric concentrations and thereby informing emissions from that accordingly. So if we want to monitor methane emissions directly, why aren't we doing it on a larger scale? Well, the problem with traditional monitoring methods is that they're both costly and complex to operate and maintain. And that limits their deployment, reducing the spatial coverage of it. So to put it into perspective, below here is a Picaro instrument that's used by NIST to measure methane emissions directly, and a unit of that costs around $50,000 to $100,000. And there's low-cost methane sensors. So low-cost methane sensors offers a promising solution to this because they're much cheaper, so they're easier to deploy on a much larger scale. But they certainly do come to their own set of challenges too. So the two biggest challenges are that they have very great cross sensitivity to other environmental factors like temperature, humidity, and other gases. And another problem is that there are a lot of unit-to-unit variability, so that limits our potential to calibrate for one sensor and then apply it to all the other ones. So that makes the task of calibrating low-cost sensors a non-trivial task. So where are the methane sensors here in Baltimore? Professor Kirsten Kohler and Scott Miller talk about we have this network of
multi-pollute sensors, and methane is one of them. Before we dive into the modeling part, I want to just to show you like an overview of the data and how there's a lot of like messy noises and variability in the data availability and like how accurate they're monitoring and this stuff. So right now I'm spending a lot of time on designing and implementing like the most rigorous and robust data pre-processing pipelines so that we can feed in reliable data for the model to learn, because model is only going to be as good as the data you feed into it.
So thanks Bowen for introducing the cost messing sensor and the search network. In comparison with search network, there are reference instruments implemented by NIST measuring methane concentrations in Washington and Baltimore. They use Carroll cavity ring down spectrometer analyzers, as mentioned in previous slides. It's considered as golden standard, but very expensive. It's quantifying greenhouse gas fluxes in the urban areas. In order to compare our low-cost methane sensor with reference instruments, we have two low-cost multi-pollutant monitors co-located with NIST reference instruments at two tower sites, HAL and NEB. These two sites are circled in red on the map. So here's a flowchart of our research overview. Based on co-location measurements, we develop a calibration model. It corrects low-cost methane measurements with temperature, humidity, and other sensitivity predictors. Then we predict reliable methane concentrations. So we try different types of calibration models. First, we develop multilinear regression model. It performs pretty bad with R-square of 0.17 in both training and testing data set. Then we switch to a machine learning model. We use random forest algorithm. It performs significantly better. It has R-square of 0.95 in the training data set and R-square of 0.75 in the testing data set. The random forest algorithm is an ensemble machine learning algorithm. It creates a magnitude of decision trees and make a single prediction based on decision trees. Our calibration model is expressed as reference methane equals to a function of raw sensor methane, hour of the day, absolute humidity, temperature, carbon monoxide, PM2.5, carbon dioxide, and sensor drift. Predictors considered in our calibration model include internal multi-pollutant monitor measurements of absolute humidity, temperature, carbon monoxide, and PM2.5. Reference methane and carbon dioxide are measured by NIST tower sites. So the inclusion of absolute humidity, temperature, and carbon monoxide are based on results from previous laboratory evaluations, during which our low-cost methane sensor shows response to and sensitivities to these predictors. The selection of carbon dioxide, PM2.5, and sensor drift is based on R-square and rooming square error. Including these predictors in our calibration model significantly increase prediction power. So this two-time series plot shows a comparison between reference methane and our calibration model predictions. We randomly choose 2 weeks in the summer and 2 weeks in the winter. The black line is the reference methane at HAL site, and the blue line is our calibration model predictions. Generally, our calibration model prediction capture ups and downs of the methane dynamics. It performs better in the summer when there's normally lower methane concentration and fuel strikes. So here's a timeline of our project. Currently, we are in the stage of evaluating basic and sophisticated models. In July and August, we will conduct field test and validation. We will collaborate with Dr. Peter DiCarlo and Dr. Bernard to cross-validate our low-cost methane sensor and backpack measurements. Our ultimate goal is to apply our calibration model to the Intel search network and test application of our model in real-world scenarios. With a reliable calibration model and the search network, we are able to recommend effective monitoring strategies for other regions and better understand urban massing dynamics. We are able to identify leaks in infrastructure and hotspots in areas of concern. We like to make this technology to work to the community. Imagine in Baltimore, every citizen can play a role in environmental monitoring. When a resident reports a suspected leak, it can be verified by our network of low-cost massing sensors, providing quick response and preventing potential hazards. It can increase community empowerment through participatory science. This aligns with BSEC's mission of creating community-centered urban climate observatories. We are also able to evaluate the effectiveness of current greenhouse gas control policies and provide evidence-based suggestions for policymakers. Thank you.
I was gonna ask, has this been done in other cities or places before in a similar fashion? And if not, do you know, would you share?
I believe like there are other kind of like low cost multi-polluting sensors in other cities, but I don't think there have been any efforts made into specifically methane monitoring in that network. So
Yeah, not such a large network as we have in Baltimore.
So am I correct in saying you're using the CO measurements as part of your kind of calibration? So if you wanted to look at CO, so it's, my understanding is the CO hasn't calibrated yet.
that's correct. So like all of our like other cost sensitivity or like the covariables that we feed into the model also comes from the search network, which is also all the other sensors are also low cost. So that kind of like makes the calibration more challenging, but we've tried to use like calibration models developed by like Professor Kirsten Kohler's like other students to like apply the calibration to other sensors and then use that to feed into the model. But from our preliminary results, what we've observed is that like basic machine learning models like random forest, they're basically a black box, so they're able to sort of take in noises and like the non-linear relationships, and that kind of like solves the uncertainties in other sensors for us in that process.
Again,
So
I guess I was wondering, is it worth trying to do them all together?
The
I
good
think-
news about CO too is that the gas sensors, they behave more like each other. They behave more similarly to one another. So I think that's maybe why it still works fairly well, even though it's
yeah.
That sensor is just a little bit better behaved.
Yeah, like we're definitely like we're not like 100% sure like what are all the cross sensitivity that would need to take into account for. So that's one of the area that we're actually working on.
Yeah, and Bo, you're not, so CO2, these are voltages. This is not CO PPP. Being put into a calibration model. So it's the raw voltage on bytes.
Yeah, I guess
So
my
it's like,
question.
yeah, it's basically, I think the assumption is that like, if CO is reading it, maybe some of the signal that the CO is providing should have been registered as it.
Yeah, so
If it's
two
like,
things happening is like there's actual one true process something like that, and then also just the machine learning is more predictive because things tend to trend together, right? So like,
Okay.
and some of it is like true process is predictive power.
All right, thank you very much. Next up is Ben. Where'd you get that interesting shirt, Ben?
The BSEC store.
All right. All yours.
All right, thank you. All right, so for those who don't know me, my name is Ben Allsweed. I'm an assistant research professor at Penn State. This work is supported through the principal investigators are Ying Pan, Ken Davis, and some graduate students and other researchers at Penn State. everybody's name who's up here is on Penn State, and that's one of the things that I would like to change if I can. I'd like to get some more collaboration from people who are actually down here in Baltimore. So I'm gonna be talking about the Flux Towers. I'm naming them the Charm City Flux Towers, and my goals for this talk are to introduce you to what we're doing, but also to kind of sell it to you and hopefully get some more collaboration from, you know, people who are doing other science and other modeling. And, you know, I'm going to tell you what I can bring, and then hopefully we'll have a better understanding. Arrows. Yeah. Okay. So the structure of this is going to be what, why, where, and what next. So what are we doing? Okay, you've heard of this. We're going to put up 2 eddy covariance towers and turbulence flux towers in Baltimore. We're going to put them up for 2 years each. Each tower is going to consist of 2 systems. 2, 2, 2, 2. Here's a picture of one of them. This is the one that's going to be in Howard Park. We're using cellular and cell phone antennas. This way we don't have to actually build our own structure. The system's going to look something like this. Okay, so one of the systems is this Campbell Scientific infrared gas analyzer and sonic anemometer combined. This is what the brains of the box are going to look like. This has been where I've been living for the past couple of months. So system 1, as I'm calling it, is going to be the top level, and each tower is going to be basically a mirror image of each other with slightly different heights. But at the top level, we're going to have temperature, relative humidity, solar radiation incoming, outgoing, thermal radiation incoming, outgoing. We're going to have 3D wind, CO2, water, and methane fluxes. At 4 levels beneath that upper level, this is going to be, I'm calling this the turbulence tree. Okay, we're going to have 4 Campbell CSAT-3B sonic anemometers and 4 temperature and humidity sensors. Top level is going to be operating at about 10 hertz minimum. These sensors are going to be operating at about 100 hertz. If you want to hear more about this data and this system, please talk to Ying. She knows way more about it than I do. Do I want to do this? Okay. Eddy covariance, briefly explained. So why I attempted to do this before and I failed miserably. So I'm going to briefly touch on this. Okay, eddy covariance is a micrometeorological technique where we can make inference about an area from a measurement at a single point. The reason we can do this is because there's characteristics about the atmosphere, such as its turbulence, that essentially let us cheat with some assumptions, and we can make some measurements about an area that's underneath the tower, in this case, arching trees. In our case, it's going to be the city of Baltimore. And it usually comes out as a per meter squared basis. Why are we doing this? So one of the main reasons we started this is we have all these atmospheric measurements. That's a big one. We saw those at the morning yesterday. That's going to be telling us what is the boundary layer doing. These measurements will help us understand why is the boundary layer doing what it's doing. So here's a diagram of what we think the urban boundary layer looks like and how it might develop. We're going to sort of evaluate these assumptions. It's going to help us evaluate some other stuff. I'm going to get more into that later. Where are these systems going? Okay, so here's a nice map of Baltimore that Jason Horn made. This is other atmospheric measurements that are being taking place, top of the LiDAR, the SODAR. The 2 flux towers taking place in Broadway East neighborhood and the Howard Park neighborhood. The Howard Park neighborhood on the western side, on the left-hand side, is this one. This is approximately what the tower is going to be seeing. We don't really know exactly what direction it's going to be looking at any given time, but this is about the fetch of what we might see from the Howard Park flux tower. And you can see as compared to the Broadway East flux tower, I saw this stick earlier and I really wanted to. Broadway East. So less green space, more row houses, fewer trees. Slightly more green space, bigger houses, or more single family houses, larger lots, more trees. Okay, so theoretically, this is a kind of a classic space for time substitution. Maybe one day Broadway East would look like this, or if this gets developed, maybe it'll look like this. We're going to make a comparison between these two and see what happens. What might we see? These are not up and running yet. Sorry. This is a figure from a tower in Indianapolis where it's situated such that to the west of the tower, which is on the right-hand side, is a big residential area with a lot of trees. And to the east of the tower, on the left, is an industrial commercial area. On this side, all in red, you see positive CO2 flux, micrometeorological convention. Positive means we're seeing a lot of flux coming out of the ground. In this case, we're seeing blue flux, which means flux is going into the ground. We see some productivity on different sides of the tower, from a more developed to a less developed type area. We might see something like this from the tall flux towers. We also have a bonus tower. This one we just put up in the on the property of the old Clifton Park High School campus, courtesy of Morgan State and the Courage campaign. We have a footprint analysis of where we think we might be seeing the fluxes. This is the field that we set up in, and we can see that this outer ring is about the 90% curve of, like, 90% of the data that we're receiving is coming from within this area, and we're staying within the area of the footprint. So that's very nice. We're getting CO2 flux, and we're also getting measurements of turbulent energy fluxes. So CO2 flux, you can see that there is some CO2 flux. It's positive at nighttime, which means we see CO2 coming out of the atmosphere, or out of the ground, excuse me. And during the day, we see it going into the ground, negative. We also have latent heat flux in blue, sensible heat flux in orange. And there's already some kind of interesting stuff happening here. For one, for those of you who don't stare at these sorts of plots all the time, negative 25 micromoles per meter squared per second is actually a pretty high rate of CO2 uptake. This is just a turfgrass field in the middle of the city of Baltimore, and it's actually producing or drawing down carbon at a similar rate to my old forest site. Thank you.
Grasses rule.
Grasses rule. Thank you. I had another plot to accentuate that point, but I'll get to more into that later. There's also this. There's some kind of interesting things happening here. So for one, we see latent heat flux, which is the movement of energy through evaporated water, is much higher than sensible heat flux, which is basically the movement of hot air, much like I'm spewing now. One of the things I think is interesting that jumped out to me right away was the decoupling between the sensible heat flux and the latent heat flux. Most of the time, these things move in lockstep, but at different rates. At this site, we are sort of seeing it not being quite so coupled. That might just be because we don't have that much data, or it could be for some crazy urban hydrology, eco-hydrology thingamajig. I don't know. Let's hypothesize wildly about what this might mean. Okay, what's next? Okay, for one, we gotta get these towers out. That's kind of the main one I want to get done. There was a possibility at one point that this was going to be happening this week, but I'm here instead. I'm planning to do a direct comparison of the two contrasting neighborhoods of the two tall flux towers. Other than that, I think the real power of these towers is going to be from collaboration with other people's data, other models or other observations. You know, using the towers to put that work in context, or vice versa, is kind of where the most interesting things happen. And I'm also inspired by Darren and his work with the weather stations and the community engagement team. I think these towers could be a good opportunity to do that. We've already kind of discussed. But anyway, I kind of want to replicate what Darren has done to some degree with the flux towers, although, again, the short one's probably the best choice for that. Okay, and I'm out. Well off.
So just curious of the daily CO2 curve.
Yes.
If you look at the net daily, what's the net effect? Is that an up? I see about the update.
I think it's I didn't integrate this, and it's irrelevant on a not annual time scale. It's probably a little bit of a sync.
Oh.
That's right. We could do that. Yeah. But we need to, you need to integrate over the entire year for the puzzle.
Yeah.
Yes. Thank you.
Just a note from the peanut gallery.
Peanut gallery?
Thank you, Oliver.
You're not speaking, right?
Can you guys hear me?
Yes.
Oh, right. And is it Wanda who's speaking, or is it Yiji?
It's Pete. Can you hear me?
Yes, I can hear you, Dad.
Wanda? Yiji? Hi, Pete. How you doing?
Hi. Can you hear me? Oh, my. This is Oliver. Oliver wants to measure flux towers. I'll turn my camera off.
Can you share your screen? Wanda, can you share your screen?
Yes,
That way
please,
we
he's
can
going to
stop
present.
laughing at Pete.
Well,
can you hear people talking online?
Yes, yeah, we can hear.
We can't hear you though, Wanda.
Yeah, I don't think you can hear anyone.
Oh,
Kathy.
wait. I bet you it's my bad. Hang on.
Hang on, yeah, it's down, the volume's got turned down again.
Probably when it got reset.
Try again, Wanda.
Hi,
That's much better, okay.
good, yeah. So my student Yi is going to present.
Good, go for it.
Okay, so I think everyone can can see my screen now.
Yes,
I can see it.
Okay.
we can hear you.
Okay, sounds good. Okay, so yeah, this presentation we will mainly focus on, first I'm Yi Zhi and I'm PhD candidate from Penn State University. And in this presentation, we will mainly introduce how we can reduce the carbon in building sector and also show the great potential of the building retrofit measure to reduce the carbon emission. So, okay. So for this study, according to those figures, they show the different resolution for the change of energy source. So from the energy side, if we generate the electricity, the different energy structure will contribute the different level of carbon emission. For example, the fossil fuel will emit a lot of carbon. However, the solar and wind, they're clean energy and don't have the carbon emission. So when building use the energy source is not single, and also usually it will dynamically change even within a week. So for this figure, it shows shows in 1 week how the energy change. And because of the uncertainty for the renewable energy, so it caused a lot of uncertain when we evaluate the carbon emission of building. And also because the different state and also the different E-grade, they have their own energy code and a policy to adopt the clean energy. So according to this figure, the different geographic location also show the different percentage of clean energy penetration since the year now to the year 2050. And you can see the clean energy penetration is trying to increase in the future. So how it will impact the carbon emission when we use the energy? According to those two figures, they show the different carbon emission in the different year. I use the 10 pass example. So for the left figure, this is carbon emission factor in year 2020. And the right figure show the carbon emission factor in 2050. The deep blue means that the emission factor is really high. So which means that if you use 1 kilowatt hour, it will emit a lot of carbon. So the main difference among those two figures is that in the year 2020, the emission factor is almost constant. However, in the year 2050, you can see during the noon, around the daytime, the emission factor is relatively low because of in Tampa, it has a lot of potential to use the solar energy, and which is we call the clean energy and has a low carbon emission. So when we run the building simulation and evaluate the building performance, how can we accurately evaluate the carbon emission? And also how can we evaluate the carbon emission reduction potential for building under this uncertain scenario is the focus for this study. So here's some general methods we used for the energy prediction and carbon prediction, and also for the large scale evaluation. So for the building energy modeling, yeah, maybe most of you don't have the experience about how to calculate the building energy. So we usually collect the outdoor condition, the climate, and also about the building energy code used for other building input like the heating, ventilating, and air conditioning system, and also the building envelope information. Then we have the building energy model to evaluate how the building will consume energy within 1 year. And after that, we can have the different energy consumption for different energy source. As I mentioned before, the electricity is more uncertain because of the grid trying to incorporate more clean energy. For the natural gas, which is usually used for heating, it has a constant emission factor. So we will calculate the carbon emission for a building according to the energy simulation result. And after that, we will use the large scale survey data and also the existing construction database to have the weighting factor for different building type and calculated the aggregated building emission. Yeah. So we already developed the framework. We are trying to use the school building for this study to show how to use this framework to evaluate building carbon emission. So why we select the school building? The major reason is that the school building has a great potential to reduce carbon. So for a school building, the annual emission is equivalent to the 9 million homes energy for 1 year and the 60 million vehicle within 1 year. And we will use the open source tool, which named Energy Plus, for the building simulation, because it has a comprehensive modeling capability. And also it can run the zone, the thermal, and also incorporate the system simulation. And here's the model we used for the building energy modeling. So you can see like they both are the school building, but one is for primary and one is secondary. So they are slightly different according to their area, and also because of the secondary school building is greater than the primary school. So it will have a more HVAC equipment for the more building energy demand. And the building has a different energy source, like electricity for cooling, natural gas for heating and cooking. And we will also use the energy efficient measure to improve the building performance in energy and also see how the building carbon will also impacted by the energy efficient measure. And after we implement the energy efficient measure on our school building, here's the result of the energy use intensity reduction. And you can see for the deep red, which means that the energy use reduction is pretty high. The building has a great potential to reduce energy. And according to the figure, we can see that the hot climate region, which is like Florida and also like some part of Texas, they have a great potential to reduce the energy with the building energy efficient measure. So we wonder, how about the carbon emission reduction? We further investigated 3 hot climate zones, which is like the very hot and humid shaded with pink color, and the hot humid shaded with red color, and orange and 2B hot dry shaded with orange color. And after we calculate the carbon emission factor in those 3 hot climate zones, here's the result about the annual carbon intensity reduction. And you can see that from the long-term perspective, the annual carbon intensity reduction is gradually decreased, which means that the building emission is decreased from the long-term perspective. However, from the specific year, the different region, they have a different trend. For example, for this region, this is the hot climate zone in the California, it will gradually decrease. And for this region, this is in the Florida state, it will decrease from year 2024 to 2030. However, the carbon emission reduction will gradually increase from the year 2030 to 2050. So the reason is that the 2 regions belongs to different states, and they have 2 different clean energy penetration. And according to a circle here, you can see, according to the Florida, after year 2035, the carbon emission, the clean energy penetration will gradually decrease because of the capacity of renewable energy technology, and also the increasing population will require more demand. So the dirty energy will be used to fill in the gap. So after this simulation, we also run the large scale simulation to evaluate the national scale carbon intensity reduction potential. So according to this research, we're trying to develop a framework to predict the carbon emission reduction potential in the building sector when considering the transition to clean energy. And we also examine the building retrofit measure has a great potential to decarbonize in the building sector. And also we use the K-12 school building to show the spatial temporal variability of the carbon reduction potential when we use this framework. Okay, thank you. So any questions?
A question? I'll ask a quick one, Yishi and Wanga. This is cool. How about Baltimore? Are you gonna apply these tools to Baltimore?
Yeah. Because the Baltimore is also in, you can see this study, we focus on the continental United States, and the Baltimore is also part of in this state. So in this study, we only consider the representative building, but for Baltimore, we will use the existing property database to build the building more close to the real situation of Baltimore, and then apply the same framework to evaluate the carbon emission in the building of Baltimore.
Sounds good.
Yeah, I just want to add a quick comment. And also, yes, the Rosina present her work in modeling row house. Right, she talked about thermal energy efficiency and thermal resilience. Actually, now we can also plug in Yizi's work to understand what the retrofit benefits is in terms of carbon emission reduction for those row houses.
Gotcha. All right, thank you very much. And I think this is the right thing next. Whoops, I don't want bonus tower, I want the Zoom screen. There we are. Share. Screen. Share. Adobe. Oh, go away. Just trying to be helpful. All right.
All right, good afternoon, everyone. My name is Rahman Azari, and I'm an associate professor of architecture at Penn State, and this is a collaborative project that I'm reporting on, and two of my graduate students, Elnaz Qasemi and Arjun Janardhan, are here with me. So I would like to thank them as well for their contribution. So this work will be on drivers of urban building carbon emissions in Baltimore. So the challenge and motivation in this project is that according to the Baltimore's Climate Action Plan, Baltimore released 7.5 million metric tons of CO2 in 2019. Scott told us that has been reduced to 6.7 million metric tons, but there has not been significant decrease in reduction. And then buildings contribute 64% to the total carbon emissions of Baltimore. And the city plans to reduce those carbon emissions by 30% below 2007 levels by 2025, 60% by 2030, and achieve carbon neutrality by 2045. And on the other hand, the city also needs to provide between 5,000 to 7,000 new or additional housing units every year. And that, just by making some assumption, that would translate to between 10 to 14 million square feet of additional housing units every year. And this orange color here shows the efficiency of buildings and how it is planned to contribute to the carbon neutrality of the entire city in Baltimore. I borrowed these diagrams from the Baltimore's comprehensive master plan that has been released recently, and it's under reviews and it's open for comments. So in the new comprehensive master plan, the city has categorized the housing typology into 9 to 10 different groups, primarily based on the housing prices and percentage of the owner versus renter occupancy. So A to C, which, well, I think I could use this one as well. So A to C are in these middle areas. A is the lowest density, C is the highest density. These are higher prices range in Baltimore. And then we have I to J on the other side of the spectrum, which are the lowest price range, and they are associated with a lot of vacancy, basically 35% vacancy we see in I and J. And then we have in between areas. And then the comprehensive plan also has divided the city into 3 major areas. A is the impact investment areas. These are areas outlined in yellow areas, which is planned to, these are distressed areas that there's going to be a lot of investment on. Middle market neighborhoods, these blue areas, and these are the place for most of the population in Baltimore. These are working class families. These are the places that you could make little investment, but revitalize the neighborhood. And then we have asset building areas. So the city plans basically to demolish in some neighborhoods, even to the level of urban block. And then in some other areas, there would be targeted demolition. In some other areas, the plan is to increase zoning and in this way revitalize the city, hopefully. So I borrowed this concept of a donut of social and planetary boundaries published by Kate Raworth in his book, Donut Economics. Basically, she argues that if we want to live into the 21st century, we have to operate in this safe green zone where we will be meeting the quality of life and social foundation standards. There are 12 criteria that define our social foundation, from housing to equity to etc. But then we also have to operate under environmental ceiling, and these are 9 planetary boundaries that we have to be concerned about. So in many ways, the objectives of the city reflects the challenge that the city has to meet the social foundation standards, but at the same time, they want to remain in the safe zone and under ecological ceiling. So the objectives that we have in our project is to estimate the effects of urban parameters ranging from density to rate of retrofitting to size of new construction on urban building cumulative carbon emissions. And cumulative means in the context of buildings, operational carbon plus embodied carbon. Operational carbon is the carbon related to the energy consumption of buildings. Embodied carbon is the carbon emissions because of the construction of the buildings, and that is oftentimes not reflected or not taken into account in estimations. The second objective is to identify the optimum urban density solutions to meet the housing demand while minimizing the contribution to carbon emissions. And third, identify the trade-offs that we might see with between urban density, cumulative carbon, urban entitlement, and other factors. So we did a comprehensive literature review to identify the drivers of urban building related carbon emissions. As you could see, there is a complex web of factors and relationships that affect building carbon emissions and urban building carbon emissions. I was listening to Antonia's presentation, and she mentioned 4 characteristics for a wicked problem, being demonstrating nonlinear dynamics, having I remember that not being well bounded, formatted differently by different people. So in many ways, this problem also demonstrates the characteristics of wicked problem. If we try to organize this a little bit, we see some of these factors are being building related. For example, building size and geometry, building system and design. I have to be fast. Building material choices. These are affecting building carbon emissions. There are urban factors that affecting, such as size of new construction. And then behind this, there are a set of policy-related demographic and macro level drivers that all affect these two. And through these two, we affect urban building carbon emissions. So if you define this in the context of XLRM framework, we see these factors that are uncertain. These are our levers from physical urban to physical architectural. We have to identify relationships and then metrics. So we're not going to do all of this, but we're going to measure these relationships in the context of these three primarily. So this is the work of Elnaz, my PhD student. What she's interested in is for understanding the impact of urban density and new construction on carbon emissions. So she's working on one of the neighborhoods on one urban block. We're characterizing that urban block through all of the information that is out there. We're collecting the information, we're aggregating them into a 3D model, and then we're using that to build basically an energy model and carbon emission modeling through which we would be able to identify carbon emissions of the building sector. And we're going to use multi-objective optimization and parameterization in order to identify the optimum urban design solution. So next steps for us would be to characterize the building stock for embodied carbon modeling, develop the workflow for urban design parameterization, and develop also a Kaya identity-based model for bottom-up modeling at the scale of city. So that's pretty much what they have. Thank you. Yes.
So the last bit when you talk about developing this model for this building and the carbon emissions, does that same model kind of simulate, say, indoor temperature or things like that?
Yes, we could do that.
So it would depend on, the carbon emissions would depend on that HVAC, et cetera.
Exactly. Yes. And my hope is that we would be able to use the same model for example, to understand the urban heat island as well.
Yeah.
We have not explored that, but my hope is that we would be able to do that as well.
Right,
Okay.
thank you.
Thank you so much.
Oh, if you want one more, I'm trying to get Mike's presentation up, but ask, please.
Yeah, just one question. I see that focus is embodied carbon, but we do also want to look at operational carbon, like the energy use, everything, which time would also emissions. So is the operational carbon emissions also an interest in this case?
Yes. So we're going to look at the cumulative carbon, considering both operational and embodied carbon. And these two sometimes have conflict. So you add insulation, you reduce the energy consumption, but you increase the embodied carbon. So that interaction would be captured as well, hopefully.
Optimization, it has to optimize both.
Yes, and then one other thing that we were discussing to include is the effect on urban transportation related carbon emission as well. So when you change urban density, that has implication on the transportation carbon emissions that hopefully we would find a way to quantify that.
Mozilla? Oh, yeah. Hang on, we're trying to get Mike's. There we go, yeah. There's downloads, I can't see.
So go to the folder. Click on the folder icon on the right.
Folder icon. Open it in the right thing. There, it's opened in the right thing. Cool. All right. Hello again, everyone. So thank you so much for joining us, for those of you who traveled and standing between you and getting home. So I want to make sure that we have a productive conversation, but one that doesn't go too long and I lose some money. What we want to end by talking about are the crosscut themes. So as you remember and have heard from some of the presenters earlier today and yesterday, one of the major components that we are working on through BigSec is to try to integrate across the different science areas to try to do some of the multi-objective optimization work and to build that into a feedback so that community groups are providing input on what important science questions we're asking. And then we are taking what they say and integrating it into our science, and then hopefully the science will then inform new and interesting questions that will help them understand some of the decisions they need to make, and then hopefully it's a virtuous cycle. And this is the kind of underlying premise on which BSEC, I think, from what I understand from Ben and others, was what was innovative. One of the major things that was innovative beyond the direct science and the reason that BSEC is funded as it is. So with all that, we wanted to have some time for a discussion of what's going on across those, and rather than having a whole new set of presentations, what I had each of the crosscut groups send was an update. So if you go to the link here, hopefully the QR code works. I tried to test it, or the short link here. There's an update for each of the 4 crosscuts, which I'll describe in a second. And so that what we want to talk about are those. And so rather than, again, having more presentations, especially since some of the information that is in the updates was already presented earlier today, would be duplicative to have it come up again. So we wanted to describe that. Before we get to the discussion, however, I want to describe a little bit about where we are. So I mentioned the IRB earlier. If I never hear the 3 letters IRB together in sequence ever again, I'll be very happy. But the part of the process has been making sure that we have IRB approval, because once we engage with community members, and this is true across the board, I want to make sure everyone hears this. If you engage with community members for anything that is going to go into a published paper or presentation or anything that is scientific, you need to have an IRB protocol. And it needs to be in place before you start the research. If you don't, we're not allowed to research it, and you're in violation of federal law. And your institution will not provide any help if you do that. And so please make sure anytime you are engaging community that A, you're being IRB, B, talk to us, make sure CLIA and we can coordinate and make sure everything is also happening to the EPSC. So that's the second component, but make sure that's happening. Some good news, even though it took us a long time to get this news, is that the IRB that you need is solely at your institution or the institution of the members with whom you are working. So we do not need to file a single IRB, which was some of the holdup in trying to figure all this out. It's more detailed, probably some of you need, but for some of you it's important. So make sure that you get the IRB at your institution. If there's a collaboration, then you need to kind of submit parallel IRBs. Does that make sense? Let me stop there and just ask if there's any questions on that first, because it is important kind of administratively to make sure that things proceed. Yeah.
It's a very specific question. We have addresses of people who've been to their house before, and we know they have the right trees on their property. We were just gonna send a letter like, can we come look at this one tree? Does that need IRB approval?
Are you gonna have any information in there in a report? No. That's just so that's not, because there's no, so the key here is human subjects is data that is gathered from humans that you are publishing about. It is not contacting humans.
Great.
This also so one of these restrictions also applies to the EPSC. We can refer to the EPSC as a committee in our publications as long as we are not identifying particular people on the EPSC. Because it is a committee, it is not a human. Some of the social scientists may dispute that humans are kind of central parts of committees, but in terms of the law, a committee is not a human, and so therefore it is not protected under human subject. So as long as we describe our work with the EPSC, the Equitable Pathways Steering Committee, as a committee, we do not need IRB approval in order to publish information about them. Thank you.
With my same question,
Okay.
define engagement, essentially, what is engagement?
Yeah, so engagement in terms of the common rule, and I should have the university lawyers here, instead of me saying this, but the common rule is that you are publishing information about humans in the publication itself. So if all you said was we contacted homeowners, then that is not, there's no information, they're not giving you anything. So that's the key distinction that the common rule uses in order to make the distinction of whether it's human subjects or not. Other questions? Yeah.
Since there's so many universities involved,
Yeah.
all researchers can go through their own university's IRB process. Yes, that was what we were told. If there's a collaboration between two universities, then on a particular part of the project, so then the researchers that are part of that let us know, but you should coordinate between the two. There may be a lead and a partner. There's ways that has to happen, or both can submit simultaneously. So that's so you basically submit the same protocol simultaneously.
So safer is to get IRB approved from both universities.
You need every single part, if there's a researcher involved, needs everyone needs an IRB. Who
From
touches the
their own
data
university.
from their own university. That's always the case for whatever research. How the process of how to get there is not, we don't need to get into that here. There are different ways you can do that, but everyone needs their own IRB approval from their own institution if you're using the human subjects data. Having fun yet? So any other questions? This is really the most boring part of this, but it is, I want to make sure we don't lose our federal funding by screwing it up. All right. So Antonio already talked about this. So we already talked about it. There are 4 cross-cut themes, and these are the best icons I could find to correspond with them. So there's urban heat, air quality, flooding, and decarbonization. So these were topics for those of you who are new to the project. I know we have students who've come on that were decided at the very first VSEC community meeting that we had with the community, that they were identified by community members as important areas that did sit within a single scientific theme. So that had to cut across, that's where the crosscut comes from, different scientific themes in order to understand and address the concerns the community had. And so these were the 4 areas that was a combination of what community said and what we felt we could actually model and help with from the scientific side and have the expertise on the scientific side to be able to help with. And Lisa and Hong and students, some of whom are here, did a great job summarizing all of that. If you want to look in some of the older presentations about what has, for those of you who are starting on the project, to see how we came to these 4 and where they came from and the discussion that led to that. So these are the 4. And so what I'm going to talk about now is the process for what we want to go through across all 4 crosscuts. The particular instance, ways in which this is going to be applied to each of the 4 will obviously vary given the scientific and community questions that come up, but we want to try to follow a standard kind of process so that it makes it easier on the EPSC, it makes it easier for us if we have that going on. So that's what I'm going to describe now. So what we want to have is for each of the 4 groups. So is we want a scientific lead and we want a lead from the EPSC. And so those are the 2 people who are going to help coordinate the different components of this. That's both the community engagement side and the research side. And then with those 2 people are going to coordinate with each other and then work with a small set of I think in our IRB we said 4 to 10 people within a smaller group that is going to help move the XLRM process forward. The XLRM process is very helpful, but one of the things that Tony and I have talked about is that if you have too many people in the room, it becomes almost impossible to try to make decisions. So what we're going to try to do is have representative democracy, essentially, right? So we're going to have we're going to ask the EPSC, as the group who is thinking about this, who are the right people to be in the room? And they're going to fill out the right side of this focus group. And on the left side are going to be a subset of scientists who are helping apply and know enough about the XLRM model, the underlying models, the data, the observations, to be able to respond to community's concerns so that we can move things forward. Does that make sense? Now, it's really important to know that those 10-ish people that are in the room are not the only time that people that are thinking about this. The goal is that, as you can see kind of on the sides here, each of the 2 groups are then going back and talking. So the scientists are talking to the scientists. The folks who are on this particular committee are talking to other community members and other community groups. And of course, there's crossover here. Scientists can talk to community members too. But basically, this is a coordinating group to try to coordinate the activities rather than trying to have everything happen through everyone talking all together. Does that make sense? Going cool? Okay, so that group is important because what we're gonna do is we're gonna go through this iterative process that we talked about. This is a different way to visualize some of what we talked about the iterative process. So the very first thing we're gonna do for each of the 4 groups is have a community meeting. This is gonna be large, it's gonna be a larger group. We have a set of questions for heat, and we're pretty close to air quality. The other 2 groups need to get them, but that has been, we'll talk about the IRB, but that's basically, we're gonna have larger group meetings to try to get a sense of what's going on in the community. After that, this focus group is going to start meeting, and then they're going to have to go through several steps in order to get the XRM to the point where we actually have something that can produce results. Because it may be that some community members want some metric that we, sounds great in the first meeting, and we get back and we're like, oh, we can't measure that. We don't have the instrumentation up yet, or where it's going to take us 2 years to get that. So we'd rather keep moving and not have that now. And so this second part is going to be an iterative process to make sure we get the XRM components right. So the external factors, uncertainty, the relationships, the levers, and the metrics, to make sure we have each of those 4 components. It's going to be a kind of negotiation between what's feasible and possible, what is desired, and there's going to be some back and forth there. That makes sense. Okay. So, this is the last thing I have, and then we can open up for discussion. What we're waiting for right now is the IRB approval. As you can tell, I love the IRB. That's a joke. So we should, knock on every piece of wood you can find, have IRB approval relatively soon. Heat is ready to go. So we're actually able to start this first process up here with a community meeting under an existing IRB protocol that one of our collaboration A. Smith had. So we've already had the community meeting for heat. So heat is basically just waiting to be able to initiate this focus group to start working. And as soon as we get that IRB approval, we're going to start planning that in the summer with the and the UPSC. Ava Richardson is I think, going to be the point person, the community lead that I mentioned, UPSC member. And so we can start on that as soon as we have the IRB protocol. We have questions, we have everything ready to go, we have everything, we just need the approval to have this focus group. Air quality is probably next, and so our goal is to have this community meeting for air quality at some point by the end of the summer. That's our goal is to have that initial big community meeting, and then we'll put the group together and start the process for this. We originally talked about doing all 4 of these in parallel, but it just because of the groups and where the science is and what models we had, it ended up being that we're probably going to end up doing these more in sequence and in parallel. But all 4 will keep moving, and so hopefully there will be opportunities for anyone who's interested in each of these different components to participate. So that's all I had. I don't know if any of the I know a lot of the specific groups had a chance to present. I know Ava and Julia presented on flooding, and Michael presented on the air quality, and Ali presented on the heat. And Ron, you're presenting some of the decarbonization work too. So, but if there's any questions for either me generally or any of the 4 groups specifically, this is an open time to have that conversation. Yes.
Thank you. Yeah, I was wondering if the EPSC knows this structure. That this is happening. That's one question. And the second question is that the way the EPC is framed, they make their own decisions. So I would caution that let's not pick which member will serve which team group. Let them decide that.
No, they've already done that because Ava's already been working on the city heat. It's just the city heat one because
it's city heat.
It's just city heat. It's already been decided. So what we want to do, and I need to coordinate with Leah, but basically what we want to do is come to the EPSC and say we have these 4 cross-cutting themes. Would someone like to step up to lead the air quality community engagement? Would someone like to step up to lead
I must have missed that meeting. So this has happened already.
No. This is because we haven't had the IRB approval to start all of this.
No, but Mike, I think what Sami's saying is, does the EPSC even know about this? And you did present to the EPSC last fall on the heat process, right? So we definitely, I think it's great Sami is raising. So like we need to really up that communication, but it's not brand new, right? There's been some discussion with them about what this looks like.
Yes, exactly. Sorry, thanks, Dan. So this is a formalization of what we had kind of laid out for them for the heat process last year. We realized it worked well, so now we're going to take it back and say, but we wanted to make sure we had one of the things that I have noted is the EPSC gets frustrated when we come and say, we're gonna do this, and then there's a long wait. So I wanted to get the IRB approval before we go, so we could start when we and implement it rather than. We're gonna do this, and then we need to wait for some bureaucratic administrative process. It's gonna take 6 months. So, thank you, Ben. Other questions? Thoughts? I know we need to coordinate, but any questions for any of the specific themes?
Do you have the scientific leads yet or not that either?
So we do have the scientific leads. So the scientific leads are gonna be the same people who, I mean, our first approximation. Different groups can handle this how they want, but our first approximation is gonna be the people who are leading the groups are gonna be that. So Michael Waring, and Kirsten for the air quality, Raman and Scott for decarbonization, Ben for heat and Ben and Darren, sorry, and flooding, Larry and Clay. That's gonna be our first, if you want to hand that responsibility off, we can talk about that, but that was at least our first approximation of what we're doing.
Mike, I have a question.
Yeah.
You mentioned like individual researchers will need a separate IRB approval from their own institution. How do those IRB approvals different from this particular IRB?
So I should be clear, you need an IRB approval if you are using human subject data. So one of the things, for example, if you're not gonna participate in the actual focus group itself, you're getting de-identified data. The de-identified data is no longer, also to point out things negative earlier, it's also no longer human subject data. Then we'll need a data use agreement, but that's a much easier and a much faster process to be able to put in place. So that's what we would get.
Separate from this particular.
So in order to run, so the key for us is these two components here. So the way this relates to IRB and why it's gotten held up is these two components, we need IRB approval because we want to be able to publish about what happens in the community meetings. And we want to be able to publish about what happens in the focus group because we want to be able to publish what the process is. So Antonio's presentation earlier about some of the innovation of BSEC of doing this with non-expert panels. In order to publish the research and how we went about doing that, we need to be able to describe what's going on in the focus groups and how people have participated and offered their opinions. And to do that, that is human subjects because it's identifiable to a person. And then we need that in order to publish. So that's why we need the IRB.
So you mentioned.
Sorry, the light was very bright.
So you mentioned the scientific leads, obviously communicating with everyone else. How do you or everyone kind of view that happening?
So the groups have been meeting, some more frequent than others, but the best way to get involved, and this is true across the board, I'll put in our obligatory Slack pitch here, is the best thing. Each of the crosscuts has a channel inside of Slack. So if you go there and say, can I be part of this, then you'll get signed up for all of the meetings. It's also to whenever you have a meeting, it would be really helpful. What, Matt, what's the address for the calendar? We'll post it.
Yeah.
But we have a BSEC Gmail address, and if you post it, it will post your meetings on a shared Google Calendar. So if when we make the invitation for the meeting, you can have it for. So we found the best way to try to mediate between inviting everyone to everything, and everyone's calendars fill up, and it's really annoying, and no one listens to any message ever again. So this is a way you can have the targeted people you want, but then also have it available, so if other people want to get involved, they can. So include this email address in your invitation, and that will populate our Gmail calendar, sorry, Google Calendar, that you can then go to see when the meetings are. Questions?
You said, who would be the ones facilitating the community engagement of this group? That be the contact
And the crosscut, first one person, the lead, and then like the April sheet.
So yeah, so I can describe, so we actually have already done this for heat, so, so the way that that would work, and this is how it worked with Ava, is Ben gave a presentation on city heat that was aimed at the community. The past work, Ava talked about the work going on the sustainability plan. And then we broke out, we had, probably a dozen researchers that were able to run the focus groups. So we basically kind of broke up into smaller tables, and then we aggregated that all back up, so that's how that would work. We feel relatively confident about, because we've done it once. It was actually that process, we're like, oh, we should do this again, so.
You know, what was how long was it, like, the first meetings, was that like 3 months in? 3 weeks in?
How long has it been, or how long should it be? Well, this is where we got hung up in the IRB, so we had that meeting last fall. It went really well, we were excited, and then we realized that we were working off of an IRB that was not the ideal way to do this, and so then it got held up by all of the administrative apparatus of the university. So once we have the IRB, this is part of the reason why Samina's earlier question, part of the reason I don't want to talk to EPSC until we have the IRB approval, is at that point, the EPSC can decide how fast we move. Because we're not going to be at least for the IRB, we will not be the whole. There may be other things that come up, but what I was concerned about was going to EPSC and being like, oh, we have to wait. It could be 6 weeks, it could be 6 months, yeah, so.
Do you have a sense of how?
The
Like, do you have a?
Yeah,
idea
so
when
we-
they did the IRB thing,
Mhm.
like, when they.
So my sense is that there's folks on the EPSC who are interested in different elements of each of these things, and my goal would be that like one of them would be interested, and then they'd be able to coordinate with community groups because they have an interest in that particular area. To help coordinate the kind of ongoing engagement over here that's happening, and then I don't think there's a definitive answer, because I think it depends a little bit also on how advanced the models are, how long it's gonna take to go back and do some of the research and answer some of the questions, so. That's gonna have to be negotiated as both a combination of the community engagement and the science, because of the science, right, it takes a little while to get the question, it takes a little while to set the model up, to, you know, they provide some input in that first focus group, we try to put it into swim or city heat or something, and we realize that like it's just breaking, then that's gonna dictate how long it takes to get back, things like that.
Mike, I have another question. Say, after you get the IRB approval and at a later point, you'd like to make some adjustments or changes to how the focus group is going to be organized and structured, do you need to get another approval?
Yes. But again, everyone find some wood and knock on it. Amendments go much faster than initial approvals. So generally, if it's just like, we're gonna ask this new block of questions that is not invasive in any way or personal in any way, that sometimes even the staff person can just sign off on it and give you the approval. It doesn't need to go to the board. Any other questions? Before we go though. Were we doing that?
Just got a little wrap up. I don't know what we're gonna do.
Well, that's what, this is part of the wrap.
Oh, okay.
Trying to drag it on.
No, I really wanna, everyone in the room, the whole reason this meeting happened is because of Mac. And so I just wanna make sure that we, acknowledge all of the incremental, every single part, I mean, this happens, make sure the science and the engagement EPSC, and so thank you, Mac, for all the work that you do, to make this all happen, so that was it.
All right, very good. So we are now almost 20 minutes ahead of schedule. We already started the wrap up, so let's 20 minutes ahead of schedule. Any other comments we need for wrap up?
If your bio isn't on the website, please come talk to me. We're doing jargon-free bios, and there's about 15 minutes. I have time slots. We can find different times if those don't work for you, or you can send me your current bio material. I'll look up like funky words on Wikipedia, get a draft back to you, we'll go back and look. Simply talk to me if you don't have a bio up on the website.
Bio on the website, Miriam. Matt.
Well, rolling into that, we will have a new website by the end of June. So in addition to bios, we'll be reaching out to you for some other information, including some of the facts, some of the figures, and photos that you shared today, either through posters or presentations. Because we want to get some of those up on the website, or if you just have other ideas for materials that you want to be more public facing, just shoot them my way and we'll get them up there.
I have Kalia.
Yeah, I have it's more of a thought, I guess. But as I'm out and I'm talking to my board, I'm engaging people and talking about these kinds of things. I have people sometimes have interest in specific green teams. So for instance, there's one guy who's really interested in air quality. He does his own company. I think I've connected him to maybe a couple of people, but I'm not sure what the topic has been. But I'm wondering from the researchers, I guess, and this is something we can follow up on later, and how I can follow up with the community engagement team for how we incorporate or include people into the research that are not on the steering committee and may not necessarily want to be on the steering committee to be a part of decision making or anything like that, but they may want to connect with researchers and specific theme teams. What are you all's capacity, or how do you feel about inviting, you know, a community member that may want to sit in on a meeting? Or I don't know if the best way to do that is to invite them to the monthly seminars that you all host. So that's kind of just a thought that I'll talk through with the engagement theme team, but also one of the researchers' perspective on how you feel about having, you know, someone that may not necessarily be on the steering committee going in, maybe add something.
So we mentioned we meet every 2 weeks. I think we'd be happy to have any committee member come to any meeting. My only concern is though that we will not probably cater to them being at the meeting, and so I don't want them to feel like, I don't know, they weren't a part of the meeting. Like we have the set schedule we're going through. If anyone wants to show up, that's absolutely fantastic. We don't necessarily have something baked in about like community questions. We could consider doing that if that was best practice going forward.
Darren.
Yeah, I think my suggestion would be you contact the theme leads and tell them that someone's interested, come get there. Decide, because all the themes are very different.
Right.
And so that would be the best way to do it. And I guess this idea that the steering committee is the only community people we interact with, that's not my view. I thought the steering committee was to give us advice, but we should be interacting with a much more.
Yeah, and I think that's maybe something that we just talk about, we said, is how do we engage people that are not just on the steering committee, there are people that want to be involved.
And not only with the weather side, with the weather stations, that's what we're doing. I've got a list of people that I'm not very good at keep communicating with, but I'm trying. So that's, I think that if we only, I'd be concerned if the steering committee were the only community people we were listening to.
Right. No, I think the steering committee is only the advisory committee, and the more scientists show up in communities and spend longitudinal time, they build trust with the rest of the members of the community. That is what is needed, and I think we can help facilitate that, if you so desire.
Yeah, from my perspective, I think the theme meetings are a good place, just that they said they usually, you know, got a job to do on a given day.
Right, so that's why I think you should talk to the theme leads, not just point them straight to the theme. Some of them would be terrible to dial in.
It's just a question about, do you have a sense of any people from the community having things like events or things that they want researchers to come to? Yeah, I definitely have like I get a list of like calendars from different community meetings. We've been invited to a few different meetings to speak, or I've been to things that they would like to have researchers come. I know one thing that I requested a while back was, I know we have the crosscuts, but I was requesting that maybe each theme team have one person on that theme that not necessarily is doing community engagement, but is that point person, because maybe the person who's the lead doesn't necessarily want to do community engagement, but maybe there's someone on the thing team that wouldn't mind going to a community meeting. So if every day team would have that person, then I would know, okay, let me talk to so-and-so to invite them because or connect them to this person. So maybe that's something we could do.
I think to add to the events, this is the season of markets. There are markets across the city. Show up to the markets and increase. I mean, we may not know some people that you will bump into. So don't just look at the community engagement team leads to connect you to the community. Baltimore is a beautiful city with a variety of patches of networks of neighborhoods. Show up in all of them. Just kind of enjoy the beauty and resilience of the people who've been wronged, but they still survive and they're not going anywhere. So show up to these places and events regularly. So and wear the t-shirt. So this becomes like a, homegrown network of scientists who are really trying to connect with the community in a genuine way. And connect us to people you bump into so that our community outreach increases and it's not limited to me, Tanya, Leah, and James connecting you to our contacts or the steering committee.
And I
Enjoy the city.
I do have a QR code that I can share on the flyer with the general interest form. So if anyone is out there at a meeting or comes across a community member that they want to know more information, that QR survey has the theme teams listed so they can decide what theme team they may be interested in, their name, email, if they're a part of an organization, and then they have a link to their website.
Maybe have a stall, maybe we can have a research stall in the market so that people know what we are doing.
Suggestion along those lines, from my perspective, is a bunch of folks that would like to participate, but it's hard to know when it's valuable versus just, oh, this would be fine if anybody's interested. So, it might be good to have from the community engagement team to say, here are high priority events. We should make sure somebody's
You
here.
can do that, yeah.
And then we can kind of
can
share
do
the load and make sure we get somebody in there. But
So
if it's just like, everybody's invited to everything, then you have a hard time for everything.
Yeah.
Yeah, and if everyone is on the calendar, I do put events like that on the reset
Yes.
calendar.
Yeah.
So you can see it if you're.
It can be tough to prioritize to some degree, and you're not sure, is anybody else going, or should we really pull somebody to make sure we show up?
Yeah.
Because I think we'll
That's
show
the-
up, if we can say, this one, we need, 2, 3 people for sure, we can do it. Then,
Just from a Penn State kind of selfish perspective, sometimes like those events come up, I'd be happy to go, but it's like too
Yeah.
short a notice.
Yeah.
And it's like, I'd like to participate in, but it's harder being further.
good. Now I have one short announcement, just in case you haven't had enough meetings. We're meeting tomorrow. It's not BSEC, it's Courage, which is the DOE Armed Mobile Facility deployment that is going to come to Baltimore and the surrounding regions starting in December. The proposal was submitted almost 2 years ago, because it was 2 years ago? Almost 2 years before the deployment, about a year and a pinch ago, because there's a very long lead time on this. And it's mostly a planning meeting. We'll go over the basics of what the project is about first. Then we'll have a few more presentations about some additional measurements that are being sought or planned to build on that. Then the afternoon will be kind of a planning discussion for what are we going to do to take advantage of the additional resources coming to town. That's up tomorrow. It's open. It's a different Zoom link, but it's hybrid also.
I was gonna say, are the EPSC invited to that, or are they?
If they wish to, yes. Have we sent a specific invite? I have not personally, but I'm,
If there is a link, can you share it?
yeah, sure, absolutely. Yep. I can get it specifically to use, only if that'd be efficient.
That'll be efficient.
Will do. All right, I generally would say I think this was successful. Yeah. Lots of good presentations, lots of good discussion,
Great posters.
good posters.
Yep, so one last announcement. My weather station tells me it's pouring down with rain. But also Mac has got refreshments left over, so if you don't want to get wet and you want to stay, you can finish off. Otherwise, Mac's gonna take you back to his house.
Good job.
All right, thanks, everybody.
Thank you.
Thanks so much, y'all.
I will.
Next meeting. Understand.